Okay, can you hear me? Am I audible? Can you hear me? Okay, I think now I'm audible to you. Yes, perfect. So let's go for now mechanical vibration topic. I believe a 2 mark question positively comes from this topic and a very simple topic. I will try to complete it in 2 to 3 lectures. That means 5 hours. I think I'll take 5 hours to complete mechanical vibration. In that, I'll be giving you some 50, 60 questions, probable questions from where you can think of some question to come. And I have already sent you the questions which I'm going to discuss today. Theory I'm going to discuss here, short notes this also I'm going to provide you immediately after the class. I'll send it to you on the WhatsApp groups we have, and let's go for it. Mechanical vibration all we need to know from exam perspective, so let's start with that only. Mechanical vibration, when we talk about vibration, then this vibration is to be analyzed. This is a to and fro motion basically. This is to and fro motion from to and from mean position. So when we say to and fro, then what is the meaning of to? That means towards. What is fro? From the mean position. Typical example which I can give you of to and fro motion, that is of spring mass system. So suppose I give you a spring mass system like this. Spring mass system, if I give you like this is the mean position. I'll say this is the mean position. Now if I basically deform it from its mean position, then it is going to oscillate from its mean position. It is going to oscillate something like this, towards mean position, from mean position, something like this, to and fro motion, towards and from mean position. Spring mass system, pendulum, cantilever, beam, shaft, whirling shaft, window panes और vibrating, ये सारा vibration का example है. And let me tell you very beginning in the very beginning of the lecture, YouTube के ऊपर you are getting so many good teachers teaching the subjects. They are very wonderful teachers there. My advice to you is, whenever you go for some topic, you do it completely. Otherwise, it is a wastage of time. Suppose you started vibration with me and then after 1 hour, 2 hours, you left it. That is wastage of 1 to 2 hours. So either you invest 4 to 5 hours in which I complete it totally, then only you can solve the question, because incomplete module at one place is the sheer wastage of time which students are doing. Don't do that. Complete it thoroughly. So this is the vibration example we have taken, spring mass system. Now this is a to and fro motion, something like oscillatory like this. Now suppose I put a pen. Suppose I put a pen here. I put a pen here. It is oscillating like this. And suppose I move this screen here. Then what is going to happen is this. It is going to basically move something like this, sine graph or cosine graph. It is going to oscillate like this. So that means this particular thing is representation. This is the trigonometric representation of to and fro motion. साइन ग्राफ है ये, कोसाइन ग्राफ भी इसी को बोलते हैं. साइन एंड कोसाइन ग्राफ एक ही जैसा दिखता है, ओनली थिंग डिपेंड्स इज फ्रॉम वेयर यू स्टार्ट. तो साइन एंड कोसाइन ग्राफ दिखते हैं. So the moment you go for it, let's say this is x and this side is a t. X is the position from mean position, distance from the mean position. So sometime the particle is at the mean position and sometime it is far away from the mean position. And maximum value of body from mean position we will call amplitude. तो x का मैक्सिमम वैल्यू को मैं एम्पलीट्यूड बोल दूंगा, वो बाद में डिस्कस करता हूं आपके साथ. तो जो भी बॉडी ऑसिलेशन या वाइब्रेशन करता है, उस बॉडी को मैथमेटिकली मैं एक साइन एंड कोसाइन फॉर्म में रिप्रेजेंट करता हूं. वो साइन एंड कोसाइन कहां से आता है? तुम देखोगे अगर ऐसे से वाइब्रेट कर रहा है और मैं एक मूविंग बॉडी के ऊपर पेन लगा दूं तो ऐसा ग्राफ बनेगा. फॉरगेट अबाउट इट. बट रिमेंबर वन थिंग, if the body starts oscillating from here, goes to the extreme position, comes back, then we say one cycle is complete. तो कैसे बोलते हैं वन साइकिल कंप्लीट हो गया? अगर सर वो बॉडी पूरे का पूरा एक 360 डिग्री या आपका पूरे का पूरा आपका एक सर्कल कंप्लीट कर ले, तो मैं बोलता हूं साइकिल कंप्लीट हो गया। मींस जहां पे वो पहले बॉडी था वहीं पे दोबारा वापस पहुंच जाए। Again, see carefully. Suppose body is moving here, body is moving like this, body is moving like this, body is moving like this. So you will find that position 1 and position this 2 are the position जहां पे body exactly same situation में है। तुम देख रहे हो एरो, तुम देख रहे हो एरो, तो बॉडी जब मूव करते करते दोबारा उसी पोजीशन पे वापस पहुंच जाए, हम बोलते हैं एक साइकिल कंप्लीट हो गया। वन साइकिल इज कंप्लीट। नाउ सी हियर, स्टार्टेड मूविंग दिस साइड, then started suppose moving this side, comes back, goes this side, comes back, again it's ready to move this side the way it was, so हम बोलेंगे एक cycle complete हो गया। So this particular is one cycle complete. T is the time period of the cycle, and you know this graph is represented as x is equal to a sine of theta. You know this particular thing is the sine graph और कोसाइन ग्राफ। अभी मैं एक सिंपल हार्मोनिक मोशन की तरफ जा रहा हूं कि सिंपल हार्मोनिक मोशन होता क्या है। वो मैथमेटिकल रिप्रेजेंटेशन है कोई भी ऑसिलेटिंग या वाइब्रेटिंग बॉडी का। वी डोंट नीड टू नो मच अबाउट दैट। लेट मी गो टू नेक्स्ट एंड गिव यू दिस डायग्राम। अब मैंने आपको एक डायग्राम दिया कि बॉडी इज बेसिकली मूविंग समथिंग लाइक दिस। ये एक ग्राफ मैंने आपको दिया, साइन ग्राफ। अब इसी का मैं एक फेज डायग्राम भी तुम्हें दे रहा हूं, एक साइकिल। ट्राई टू अंडरस्टैंड वेरी वेरी क्लियरली द मीनिंग ऑफ दिस। Let us say this body at particular point is x distance from the mean position, x distance from the mean position, let us say, or this particular body is rotating. This is called phase diagram, and this is the sine or cosine graph, sine or cosine graph. I told you from here sine and cosine graph comes out. And I'm going to discuss with you what is simple harmonic motion. Simple harmonic motion is the mathematical way. It is the mathematical analysis of vibration, mechanical vibration. जो भी body vibrate करेगी उसका mathematical analysis simple harmonic motion. Why? Because in mathematics, in trigonometry, sine and cosine are the two functions which are used for repetitive motion. Periodic motion, कोई भी motion repeat होती है because sine and cosine repeat after 2 pi cycle. And what is the meaning of 2 pi? Let us say theta here is 0 degree, theta here is 90 degree, theta here is 180 degree, 270 degree, and there again 360 degree. That means after 2 pi revolution, you will say the cycle is complete. You have completed the cycle. And what is the time? Let us say time here is 0. तो यहां पे टोटल जब वापिस आ जाएगा टाइम पीरियड कितना हो जाएगा? कैपिटल टी। तो यहां पे कितना हो गया? t/4। यहां पे कितना हो गया? लेट अस से दिस इज t/2 एंड यहां पे 3t/4 एंड यहां पे कितना हो गया? दोबारा t। सो दैट मींस when the particle started moving from mean position, this is the extreme position, let us say a, and a is nothing but this is the radius of this particular phase diagram. So there is a correlation between this graph and this graph. यहां पे तुम 0 से कैपिटल टी तक चले, तुमने एक साइकिल कंप्लीट किया। यहां पे तुम 0 से कैपिटल टी तक चले या थीटा 2 पाई तक चले तो तुमने एक साइकिल कंप्लीट किया। सो एक्स एक्सिस में रिप्रेजेंट एंगल थीटा और इट में रिप्रेजेंट द टाइम। वाई एक्सिस रिप्रेजेंट्स द डिस्टेंस फ्रॉम द मीन पोजीशन। जो मैंने पिछले डायग्राम में आपसे डिस्कस किया, जैसे से पार्टिकल वाइब्रेट कर रहा है, ऑसिलेट कर रहा है, तो मीन पोजीशन से कितना डिस्टेंस पे है, दैट उसको वेरिएबल को मैंने एक्स बोल दिया। एक्स का मैक्सिमम वैल्यू क्या है? एम्पलीट्यूड है। मीन पोजीशन से कितना ऊपर जा सकता है वो मैक्सिमम एम्पलीट्यूड, कितना नीचे जा सकता है मैक्सिमम एम्पलीट्यूड। और उसको इस ग्राफ को कैसे रिप्रेजेंट करते हैं? साइन से रिप्रेजेंट करते हैं। तो एक्स इज द डिस्प्लेसमेंट फ्रॉम मीन पोजीशन इज इक्वल टू ए साइन थीटा। भाई व्हाई यू आर टेकिंग साइन थीटा? Because sir, in trigonometry, sine and cosine are the only two functions which are repetitive in nature. Means sir, they repeat after 2 pi radian. So that is how it all goes, and hence we take it sine and cosine graph. Now this is sine graph because अगर मैं बोलता हूं t is equal to 0 के ऊपर अगर amplitude is 0, it becomes sine graph. Because you see this side, if I say theta, अभी थीटा को t की फॉर्म में हम रिप्रेजेंट करेंगे। थीटा 0 पे x is equal to 0. Why? Because sine 0 is 0. But suppose theta 0 पे it is at extreme position, then it is a cosine graph. So depends from where you are starting. So both sine and cosine can be used to represent the simple harmonic motion. अब ये ग्राफ हमारे पास सिंपल हार्मोनिक मोशन की क्रिएशन में हेल्प करेगा, कैसे क्रिएट हुआ. नाउ suppose the body is not at the t is equal to 0 is not at the mean position. Body is not at the mean position. And by the way, let me now take this triangle here. Let me take this triangle here. Suppose this angle is theta and this is a. So can you tell me what is this x? X, this is a, this is theta. X is equal to a sine theta. X is equal to a sine theta. And can you tell me what is this particular length? This is a cos theta. So I'm taking a sine theta, not a cos theta. A cos theta can also be used for vibration. So as this body goes up, then x की value increases, it becomes maximum here, that is equal to a, then again comes down, then again increases. So as the theta keeps on increasing as the time passes, x का value बढ़ के capital A तक जाता है, फिर minus A तक जाता है. So accordingly vibration keeps on going. That means we have simple harmonic motion here, which represents the cyclic or periodic motion. Now, what is the general formula of simple harmonic motion? The general formula of simple harmonic motion can be obtained something like this. This formula, please remember now. And for that matter, let me tell you now, theta is angular displacement. Theta is the angular displacement. As we know linear displacement, it is angular displacement in radian. Can you tell me what is omega? Omega is d theta over dt. That is the angular velocity. That is called angular velocity. Rate of change of this angular displacement. That is called angular velocity. Now suppose I ask you, fan is displaying which motion? You will say, sir, it is displaying the periodic motion. Okay, pendulum is displaying which motion? You will say this is the oscillation. तो हम डिस्प्लेसमेंट को वी शुड नॉट ऑलवेज सी द डिस्प्लेसमेंट इन टर्म्स ऑफ मीटर, वी शुड ऑल्सो सी द डिस्प्लेसमेंट इन टर्म्स ऑफ थीटा और रेडिएशन. और यहाँ पे जब मैं साइकिल की टर्म की बात कर रहा हूं तो हाउ मच एंगुलर डिस्प्लेसमेंट आई एम ट्रेवलिंग, 2 पाई एंगुलर डिस्प्लेसमेंट. इन हाउ मच टाइम आई एम ट्रेवलिंग, t time I am traveling. So this omega n is equal to 2 pi by t. 2 pi radian I travel in time period t. This becomes our natural frequency of vibration. Natural frequency of vibration. So this is calculated in radian per second. Because what the body, if it is displaying the vibration or oscillation, it is repeating its motion. So you will say कि सर एक साइकिल कितनी देर में कंप्लीट हो रहा है? आप बोल रहे हो एक साइकिल आपका टी टाइम में कंप्लीट हो रहा है, और एक साइकिल में कितना डिस्टेंस उसने ट्रेवल किया? मैं बोलूंगा एक साइकिल में उसने 2 पाई रेडियन ट्रेवल किया, तो उसका एंगुलर वेलोसिटी क्या हुआ? उसका एंगुलर वेलोसिटी 2 पाई बाय टी हो गया. एंड यू नो व्हाट, देयर इज अ रिलेशन बिटवीन थीटा एंड ओमेगा. सो इफ आई से this body is having angular motion, this body is having some kind of oscillation motion, and that oscillatory motion is having angular velocity omega, then theta is nothing but omega into t. Theta is nothing but omega into t. Let's say t is equal to 0, the body is at this particular position. At theta is equal, at t is equal to 0 time, body is not at the mean position, but body is at some distance from mean position. Then after time t, how much distance it traveled? After time t, how much distance it traveled? It traveled some more distance theta. And can you tell me what is theta? Sir, theta is omega into t. Why? Because it is having angular velocity omega. And is angular velocity constant? Yes. 2 pi is constant, t is also constant. So 2 pi by t is also constant. Now listen carefully again. I'm saying the body at t is equal to 0 is not at the mean position. Let us say it is at some position away from the mean position. So body is at phi distance from the mean position. After some time t, it has crossed even angle theta. Now, can you tell me what is x? Can you tell me what is x here? This is the x. X is equal to capital A, similar to this, capital A, sine of omega, that is theta plus phi. And what is this theta? Theta is nothing but omega into t. This is omega t plus phi, and this omega I said is a natural frequency of oscillation. ये ओमेगा को मैंने natural frequency क्यों बोल दिया? Why? Because this body is already displaying that rotation, और वो natural उसकी vibration हम निकाल सकते हैं अभी वो मैं आपको स्प्रिंग मास सिस्टम के साथ डिस्कस करूंगा, हाउ डू वी कैलकुलेट द नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन. नाउ फॉरगेट अबाउट एवरीथिंग. व्हाट वी अंडरस्टूड इज दिस. What we understood is in simple harmonic motion that x is equal to a sine of omega n t plus phi. Sir, can I write it as x is equal to a cos of omega n t plus phi? Yes, you can write as cos also. What is this formula? This formula is the expression of simple harmonic motion of the body. The body which is displaying simple harmonic motion, or the body which is vibrating, simple harmonic motion is the mathematical way to analyze the vibrating body. What is vibrating body? Sir, that body which is having to and fro motion towards mean and from the mean to and fro motion with very small amplitude. The body which is having to and fro motion with very small amplitude is called vibration. And what is mechanical vibration? Sir, if the mechanical force is the reason of such vibration, it is called mechanical vibration. Is the topic clear now? What is vibration? Sir, it is oscillation. What is oscillation? To and fro motion. What is to and fro motion? Toward mean position, away from the mean position. Okay. But that to and fro motion, which has very small amplitude, is called vibration. And what is simple harmonic motion? Mathematical way to analyze vibration. And what is a simple harmonic motion equation? Sir, a sine of omega n t plus phi. What is a? A is the maximum value of displacement, because this is the displacement from mean position. This is the displacement from mean position. Okay. What is omega n? Sir, this is the natural frequency of vibration of the body. How do we calculate it? This chapter we are going to learn that only. How do we calculate natural frequency of the vibration? What is T? Sir, T is the time period of oscillation. This is the time period of such oscillation or vibration. Okay, good. What is phi? Sir, phi is the initial phase. What is the meaning of that? Sir, that means at t is equal to 0, where the body was located. That is phi. As I told you, it is not always that body at t is equal to 0 is at the mean position. Body may be some away distance from the mean position. So that is called initial phase. We need to dissect this formula, because we are preparing here for GATE written exam, we are not preparing here for any interview stuff also. We are preparing for written. We need to know the formula, use the formula, calculate the answer. So start from here. Remember this formula, a sine of omega n t plus phi. And you should know every point here. What is the maximum value of x? X is the displacement from mean position. A is the amplitude, maximum value of that. This is called amplitude. What is omega n? That also you should know. And I can write it as 2 pi Fn also, where Fn is the natural frequency in hertz. This is frequency in hertz. Hertz is 1 by second. That is how it is to be done. This is the displacement of the body from mean position. Okay, now if I get displacement from the mean position, can I calculate the velocity also from the mean position? Yes. Dx over dt is the velocity. How do we do that? A cos of a omega n cos of omega n t plus phi. Done. What is the differentiation of sine theta? Cos theta. But we are differentiating with respect to time. So omega n will come out. I can represent it in another way also. How? A omega n sine of pi by 2 plus omega n t plus phi. What is sine pi by 2 plus theta? It is cos theta. What is sine pi by 2 plus theta? It is cos theta. But why I am representing like this? Because maybe I want to compare these two. Why do I want to compare these two? I want to know what is the phase difference between displacement and velocity. What is the difference between displacement and velocity as far as the phase is concerned? And we will say phase difference between displacement and velocity is pi by 2. Velocity is pi by 2 ahead of displacement. I will make that particular diagram and make you understand that. But first tell me, what is the maximum velocity through this formula? What is the maximum value of cos theta or sin theta? 1. So what is the maximum value of velocity? A into omega n. What is the maximum value of displacement? A. What is the maximum value of velocity? A into omega n. Good. Now can you tell me the acceleration? Yes, acceleration is equal to differentiation of velocity. And can you tell me what is the differentiation of cos theta? Minus sin theta. So what you get is minus a omega n square sine of omega n t plus phi. You know how I can write it? I can write this very thing as a omega n square sine of pi plus omega n t plus phi. Sine of pi plus theta is minus sine theta. Sine of pi plus theta is minus sine theta. So why I am writing in this form? Why not in this form? Because negative means phase reversal. Negative means phase reversal. So I wanted this thing to be positive here so that I can compare this and this. Now tell me, what is the phase difference between displacement, velocity and acceleration? Sir, if displacement has phase phi, initial phase or this phase, any phase, this phase, then velocity is pi by 2 ahead of displacement and acceleration is pi ahead of displacement or pi by 2 ahead of velocity. And do you see one thing here? Displacement looks like equal to minus omega n square into x. Do you observe it? Acceleration is equal to minus omega n square into a sine of omega n t plus phi. What is a sine of omega n t plus phi is nothing but x. So that means acceleration is equal to minus omega n square into x. And you know what? This is the formula of simple harmonic motion. This itself is a formula of simple harmonic motion. And one more thing, please observe here. What is the maximum value of acceleration? What is the maximum value of acceleration? Is equal to, if I do not consider the sign, a into omega n square. So what are our findings? Our findings are, what is the x? A sine of omega n t plus phi. Done. What is the velocity? A omega n cos of omega n t plus phi. Done. What is acceleration? Acceleration is a omega n square with negative sign, sine of omega n t plus phi. Okay, very good. So what is the maximum value of displacement? Sir, it is amplitude. What is maximum value of velocity? Sir, this is omega n into a. Okay, what is maximum value of acceleration? This is minus omega n square a minus sign you neglect. This is how it is to be done. So what question can be framed from here? Question can be framed, the maximum velocity and maximum displacement of simple harmonic motion is given as this. Can you tell what is the time period or natural frequency of vibration? Let me tell you, very simple questions are framed in GATE exam of 1 mark. So what question can be framed? He will give you a simple harmonic motion of the body. He will give you there is a body which is having some kind of oscillation or vibration. Maximum velocity is 5 meter per second and maximum displacement from the mean position is 2 meter. Can you tell what is the time period of oscillation? Maximum velocity is given, maximum displacement is given, time period of oscillation can be calculated. Similarly, he can give you maximum acceleration and he can give you, let us say, maximum value of displacement, and from there you can calculate the omega n square. And if you have calculated omega n square, you can calculate further as time period. So a question I am expecting from here, I am expecting one question from here, from position, displacement, from the mean position, velocity and acceleration part. Now second part is, as I told you, if you see acceleration as minus omega n square into x, you just compare these two equations and you will find that acceleration is equal to minus omega n square into x. You know, this is simple harmonic motion. What is the definition of simple harmonic motion? Sir, if acceleration is minus a displacement, if acceleration is equal to minus displacement, then it is called simple harmonic motion. Should I give you example? Take the example here. This is the spring mass system, right? Let us take, this is at the mean position as of now. Now suppose this is vibrating and going this side. This is vibrating and going this side. Can you tell me its speed is increasing or decreasing? Answer my question. When it is going away from the mean position, its speed is increasing or decreasing? You know one thing, that maximum speed of any oscillating body, whether it is pendulum or it is a spring mass system, maximum speed is at the mean position. At the extreme position, velocity is 0. So when the body is moving from mean to extreme position, its velocity is decreasing. And if velocity is decreasing, That is acceleration or retardation? That is called retardation. And what is retardation? Sir, negative acceleration. Or I can say, sir, retardation is proportional to displacement. So simple harmonic motion के केस में भाई कौन सी चीज true है? If he ask you that in the exam, as you know, you have MSQ. I don't know what is this MSQ, multiple statement questions, you know. He might give you some statements. Which of the following is true for simple harmonic motion? Acceleration is proportional to displacement? Nahin. Acceleration is proportional to minus displacement? Yes. Retardation proportional to displacement? No. Retardation proportional to minus displacement? Retardation proportional to displacement? Yes. Retardation proportional to minus displacement? No. Retardation is minus acceleration. You understand that? And now see from here. As the body is moving away from the mean position, it is retarding. And that acceleration is proportional to the distance from the mean position. Jitna tum mean position se dur jaoge, the distance increases from the mean position. Acceleration, in fact, retardation keeps on increasing. And at one point, it will stop. Now, visualize the meaning of it. You know, we said that simple harmonic motion is used to analyze vibration. Vibration is what? Oscillation. Oscillation is what? To and fro motion. To and fro. Toward mean position, from mean position. If the body moves away from mean position, at one point it should stop and start coming back. At one point it should stop and start coming back. That is only possible if while it is going away from mean position, it is retarding. Think of pendulum. Maximum velocity of pendulum is at the mean position. As it goes away from the mean position, its velocity should decrease. It should retard. Velocity here becomes zero. And again it starts coming back to mean position. So simple harmonic motion ka definition is acceleration proportional to minus displacement. Retardation proportional to displacement. As you go away from the mean position, retardation keeps on increasing. And at one point, because of that increased retardation, it becomes zero. You people have done uniformly accelerated motion equations in engineering mechanics. V is equal to U plus AT. S is equal to ut plus half of AT square, and v square minus u square is equal to 2as. These are for linear motion. If I give the analogy for angular motion, v is equal to u plus at, omega is equal to omega naught plus alpha into t. In this, alpha should be constant. But you know what? In this case, d omega by dt, which is alpha, angular acceleration is not constant. So you cannot use those equations here. Why? Because alpha is not constant. Why alpha is not constant? Because alpha depends upon displacement. As you go away from the mean position, as the theta increases, alpha also increases, though it is negative. So you cannot use uniformly accelerated motion equations in this particular case. This is a simple harmonic motion, you should know. Second thing is phase diagram. Phase diagram. What is the meaning of phase diagram? Sir, phase diagram means where entire simple harmonic motion or oscillatory motion I visualize in terms of a circle. Because the moment I complete a circle, I mean I complete a cycle. And simple harmonic motion, या oscillation में I complete a cycle. So let us say this is the displacement. Go 90 degree away, it becomes velocity. Go 90 degree further, it becomes acceleration. Now answer my question. What is the phase difference between velocity and displacement? 90 degree. आगे कौन है? पीछे कौन है? Which is lagging, which is leading? Velocity is leading, displacement is lagging. Acceleration, displacement. Acceleration is leading, pi phase ahead, and pi phase means phase reversal. Acceleration and displacement are reverse. Negative means phase reversal. So acceleration and displacement phase reversal. वहां पे phase का reversal हो जाता है. That is why you get this phase reversal. So have you understood now simple harmonic motion? What is the maximum value of displacement, velocity, acceleration? This is how we understand the simple harmonic motion here. Okay, now I think this first part is done with us. So let me give you how to find out natural frequency. There are some methods, you know, methods to find natural frequency. Methods to find natural frequency. अब ये natural frequency होती क्या है? We will call natural frequency as omega n. What is this natural frequency? You know, any body, any particular body which has mass or inertia and elasticity. Any body which has inertia and elasticity will vibrate once you apply some kind of energy on that body. That energy is going to be stored in the form of its elastic potential energy. You know, stress strain diagram you people have done. This I'm giving you stress strain diagram of mild steel. Stress strain diagram. You know, this area represents the elastic potential energy stored per unit volume, and that is basically modulus of resilience. And if I take total area, it becomes modulus of toughness. This particular thing is basically elastic potential energy. This is elastic potential energy stored per unit volume. You understand? And that elastic potential energy which is stored in the volume body is the main reason of its vibration. Is the main reason of its vibration. सपोज आई अप्लाई फोर्स, ट्यूनिंग फॉर्क आपने देखा, ट्यूनिंग फॉर्क मैं ऐसे फोर्स लगाता हूं और वो जो मैंने वर्क किया, दैट वर्क इज स्टोर्ड इन द फॉर्म ऑफ इट्स इलास्टिक पोटेंशियल एनर्जी. It should have elasticity and it should have inertia. If these two things are there, then the body is going to display mechanical vibration. Now, natural frequency of the body means the body, whenever you apply force, how that body is going to vibrate. Because in stress strain diagram, if I ask you, do you know its yield strength? Yes. Do you know what is a modulus of elasticity? Yes. So all these things are material dependent things. Natural frequency of the vibration also depends upon the body. It depends upon some mechanical properties of the body, and hence it is fixed. In case of spring mass system, I will tell you that will depend upon the mass and that will depend upon the stiffness or the spring stiffness. So that is how these things are decided, elasticity of the spring, and then we can calculate natural frequency. So what is natural frequency? Sir, how that body is going to oscillate or vibrate naturally if I apply force on that, or if I give energy to that, how it is going to oscillate or vibrate. That is basically natural frequency of vibration. Now, how to find out? There are three methods to find out natural frequency of body. One is called equilibrium method. One method is equilibrium method, and you always remember the names of this method. Equilibrium method means whenever the body is oscillating in equilibrium, net forces acting on that body, net forces acting on that body, and net movement will always be zero. Let us say I have displaced this body away from the mean position. Then there are two forces. Let us say model this spring stiffness is K. Then the spring is going to apply a force Kx this side, and yes, acceleration is also towards the mean position as we know. So this mx double dot. So equilibrium method says what is the net forces acting on the body. If you see the Newton's second law, net force is equal to m into a. Net force is equal to m into a. So m into x double dot, that is a net force acting on the body. But you know what? If the body is moving in this direction and this direction we are taking as positive, then this force is to be taken as negative force. Body is moving this side, so the net force is acting. Spring is pulling it back to the mean position. The spring is pulling it back to the mean position. That means minus kx. So mx double dot plus kx is equal to 0. Can I put it like this? Plus k over m, x is equal to 0. And why don't you compare this very thing minus k over m into x? Can you compare it with minus omega n square by x? You see this? And that simply means omega n is equal to k over m under root. Natural frequency of vibration of spring mass system is the spring stiffness over its mass. And what is this? This is the elasticity, you know, spring stiffness. Spring stiffness. And what is m? M is the mass, which is nothing but inertia. And as I told you, for any system to vibrate, two things are required: elasticity and inertia. Elasticity is in the spring stiffness and inertia is in the mass. So what is the natural frequency of vibration? Sir, उस body के अंदर natural क्या traits हैं and वो कैसे vibrate करेगा if you displace it from its mean position. So the moment I displace the spring from the mean position, spring force acts towards the mean position. Let's say the spring is moving x in this direction is taken positive, so kx is upward minus kx. As per Newton's second law, whatever external force is acting on the body is going to accelerate the body. You understand that? So m into acceleration is equal to net force. Net force is minus kx, bringing it back. You add it up, you compare it, natural frequency of vibration is this. What is equilibrium method? Whenever the body is oscillating in the equilibrium, net force is acting on that, or net movement produced is going to be zero. There is no net force or net movement acting. That is called equilibrium method. This is method number one. And what is method number two to find natural frequency? That is the energy method. Second is energy method. We know that total mechanical energy, which is kinetic energy plus potential energy, is equal to constant. Okay, what is kinetic energy? Half of m into x dot square, mv square. What is potential energy? That is equal to half of kx square, elastic potential energy. If we're talking about, so if you differentiate it with respect to time, that is half of mx dot square plus half of kx square is equal to 0. If you differentiate it, again you are going to get the same thing. What is the differentiation of x dot square? It is 2x dot x double dot plus half of k. What is the differentiation of x square? It is 2x into x dot is equal to 0. If you solve it, what you get is again mx double dot plus kx is equal to 0. Same thing you are going to get. So what is the second way to calculate natural frequency? Energy method. What is the first way? Equilibrium method. Equilibrium method talks about the forces and movement. Energy method talks about the total mechanical energy. And you know what? There's a third method also, which is called Rayleigh method. बस नाम याद रखना important है. Third method is Rayleigh method. This third method is called Rayleigh method. What is that? It says maximum kinetic energy. Maximum kinetic energy is equal to maximum potential energy. Maximum potential energy. Can you tell me what is maximum kinetic energy? Half of m into x dot square, but maximum value is equal to half of k maximum square. You put the value of maximum velocity, you put the value of maximum displacement, and you will calculate the meaning of this. So what is the maximum kinetic energy, maximum potential energy? कैसा क्वेश्चन आएगा इसमें से? कौन से तीन मेथड्स हैं which are used to calculate natural frequency of oscillation or vibration? Three methods are energy method, एनर्जी की बात करता है, रेले मेथड मैक्सिमम एनर्जी की बात करता है, इक्विलिब्रियम मेथड मोमेंटम एंड फोर्स की बात करता है. सो विच ऑफ द फॉलोइंग मेथड्स कंसीडर द फोर्सेस acting on the oscillating body to find out its natural frequency? Equilibrium method, energy method, Rayleigh method, all of them, none of them, something like that. Understand? So this is how question can be framed. And you know what? This can be used to analyze any of the vibrating system to find out the natural frequency. Now, let me give you vibrating systems. Let me tell you vibrating system. How shall we classify the vibrating systems? एक classification vibrating system की है as far as the direction is concerned, and एक है as per basically the some kind of friction. Let me tell you, these are the two ways I can differentiate vibrating system. Number one, longitudinal vibrating system. Number two, transverse vibrating system, torsional vibrating system. These are the three ways I can differentiate the vibrating system. Longitudinal vibration system क्या होता है? Vibration is along the length of the body. You see, the length of the system is this, and the body is also vibrating like this. Transverse क्या होता है? Transverse होता है सर ये, लेंथ किसी और डायरेक्शन में है, कैंटिलीवर. यू नो दिस कैंटिलीवर, दिस इज हाउ इट इज वाइब्रेटिंग. लेंथ कौन सी है कैंटिलीवर की? दिस इज द लेंथ ऑफ द कैंटिलीवर. एंड हाउ इट इज वाइब्रेटिंग? ऑसिलेटिंग परपेंडिकुलर टू दैट. टॉर्शनल, you know, pendulum. How the pendulum is oscillating? Sir, pendulum is oscillating in angular way. So one of the classification of vibrating system is depending upon the direction of vibration. If the body is vibrating along its length, it is called longitudinal. Perpendicular to its length, transverse. Angular, torsional. These are the three ways to analyze the vibrating systems. Direction of oscillation. Another way by which we can differentiate is friction is existing or not. Number one, natural vibrating system. Natural does not exist. It does not exist. Natural vibrating system does not exist. Understand? So in this case, we do not consider the friction. Like ideal gas does not exist. This also does not exist. लेकिन इसको हम analysis करते हैं for simplification of analysis. We do that. Then comes, and this is also called undamped. Damping, undamped, because friction को हम लोग damping term से discuss करेंगे in vibration. Friction means damping. Second comes damped vibrating system. Third comes forced vibration system. And you know what forced vibration system means? मैंने एक cyclic force लगाया, मैंने एक cyclic force लगाया और इस टर्म के साथ एक टर्म ऐड होती है जिसको बोलते हैं रेजोनेंस. रेजोनेंस इज अ थिंग विच इज रिलेटेड टू फोर्स्ड वाइब्रेटिंग सिस्टम. तो इफ समबडी आस्क यू सारे वाइब्रेटिंग सिस्टम को कैसे एनालिसिस करोगे, कैसे क्लासिफाई करोगे? सर सारे सिस्टम को क्लासिफाई करने का तरीका एक तो ये है लॉन्गिट्यूडनल, ट्रांसवर्स, टॉर्शनल, एक नेचुरल, डैम्प्ड, फोर्स्ड. और ये रेजोनेंस कहां पे आता है? सर ये रेजोनेंस जो आता है ये फोर्स्ड वाइब्रेटिंग सिस्टम के साथ आता है. अभी कॉम्बिनेशन कैसे बनेगा? वी आर गोइंग टू एनालाइज undamped longitudinal, undamped transverse, undamped torsional, then damped longitudinal, damped transverse, damped torsional, then forced this, forced this, forced this. That is how combination can be there. But you know good thing is आपके एग्जाम में सारे कॉम्बिनेशन से क्वेश्चन नहीं आता, सारे कॉम्बिनेशन से क्वेश्चन नहीं आता. आपके एग्जाम में जिस कॉम्बिनेशन से क्वेश्चन आता है दैट इज व्हाट वी आर गोइंग टू डिस्कस नाउ. आज के लेक्चर में मैं क्या करवाने वाला हूं? आज के लेक्चर में मैं ओनली नेचुरल वाइब्रेटिंग सिस्टम करवाने वाला हूं. नेचुरल वाइब्रेटिंग सिस्टम, दैट मीन्स व्हाट सर? दैट मीन्स अनडैम्प्ड. आर यू गोइंग टू कंसिडर damping also today? No, I'm not going to consider damping today. But are you going to consider that longitudinal? Yes, I'm going to consider longitudinal, undamped or natural vibrating system. Can you give me the example of that? Yes, beautiful example is spring mass system. Beautiful example here is spring mass system. Okay, if I give you a spring of stiffness K and mass M, how do you find the natural frequency of its vibration? अभी तो किया हमने. Natural frequency of the system which can be written as this is equal to K over M under root. ऐसे इसको निकालते हैं. K is the spring stiffness, M is the mass. But you know what? I will discuss something very very important with you now. मैंने आपको बताया कि किसी भी सिस्टम में जो वाइब्रेट कर सकता है we need to have elasticity and we need to have inertia. We need to have elasticity and we need to have inertia. Let me give you a spring to you and then मैंने उसके साथ mass attach किया and you know what? उसके अंदर एक deflection आया जिसको मैंने static deflection बोल दिया. What is static deflection? Sir, deflection produced by the weight जो आपने जोड़ दिया, that is called static deflection. The deflection produced because of the weight you attached is called static deflection. Let us say that is delta. Free body diagram लेते हैं इसका. इसका weight लगा नीचे की तरफ और इसने K डेल्टा फोर्स लगाई ऊपर की तरफ. तो इन दोनों को अगर मैं इक्वल कर दूं, mg is equal to K डेल्टा. क्या निकालना है मेरे को? सर K over M. क्या होता है वो? G over डेल्टा होता है. तो can I write it as G over delta also? Yes sir, I can write it like this also. अब ये तुम्हारे पास नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन का एक बहुत इंपॉर्टेंट फॉर्मूला बन गया, जनरल फॉर्मूला बन गया कि नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन इज G over डेल्टा. अच्छा डेल्टा क्या होता है? स्टैटिक डिफ्लेक्शन. लेकिन होता क्या है डेल्टा? होता क्या है? डेल्टा बेसिकली इज द डिफ्लेक्शन प्रोड्यूस्ड अंडर अप्लाइड फोर्स. So basically the deflection under स्टैटिक फोर्स, जो मैंने स्टैटिक फोर्स या मैंने लोड लगाया उसके नीचे की डिफ्लेक्शन, स्टैटिक लोड मैंने mg लगाया उसके नीचे की डिफ्लेक्शन इज डेल्टा, दैट इज कॉल्ड बेसिकली द स्टैटिक डिफ्लेक्शन. तो g ओवर स्टैटिक डिफ्लेक्शन. अब ये डेल्टा ये कहां पे बेनिफिट करेगा फॉर्मूला हमें? यू सी, जितने भी तुमने बेंडिंग ऑफ द बीम्स देखा है, कैंटिलीवर बीम जो ट्रांसवर्स वाइब्रेशन करते हैं, वहां पे आपने स्ट्रेंथ ऑफ मटेरियल चैप्टर में डिफ्लेक्शन पढ़ा है. that deflection is this deflection delta. So अगर मैं लोड दे दूं एक कैंटिलीवर पे या बीम पे, डिफ्लेक्शन का फॉर्मूला हमारे पास है, तो ट्रांसवर्स वाइब्रेशन कैन बी कैलकुलेटेड यूजिंग दैट. ये फॉर्मूला याद रखना है. नंबर 2, एक और क्वेश्चन यहां से क्या आता है, यू नो एक्सेलरेशन ड्यू टू ग्रेविटी चेंजेस विद सर्टेन पैरामीटर्स. इफ यू गो ऑन द सरफेस ऑफ मून, तो एक्सेलरेशन ड्यू टू ग्रेविटी अलग हो जाएगा. एक्सेलरेशन ड्यू टू ग्रेविटी, जैसे से मैं हाइट पे जाता जाऊंगा एंड बहुत ज्यादा हाइट पे चला गया, तो एक्सेलरेशन ड्यू टू ग्रेविटी डिक्रीजेस. नो, लेट मी आस्क यू क्वेश्चन. इफ आई टेक माय स्प्रिंग मास सिस्टम, लेट अस से एट 3000 किलोमीटर्स फ्रॉम द सरफेस ऑफ अर्थ, यू नो अर्थ का रेडियस इज 6400 किलोमीटर्स. अगर मैं स्प्रिंग मास सिस्टम को स्पेस में ले जाऊं, 3000 किलोमीटर ऊपर ले जाऊं, हाउ दैट इज गोइंग टू अफेक्ट द टाइम पीरियड ऑफ ऑसिलेशन या नेचुरल फ्रीक्वेंसी ऑफ ऑसिलेशन ऑफ दिस सिस्टम? Answer, it is not going to affect it. Why? Because do not only see G, see delta also. Both G and delta are dependent. अगर मैं स्प्रिंग मास सिस्टम को स्पेस में ले गया, mg अगर कम हो जाएगा तो भाई डेल्टा भी तो कम हो जाएगा. अगर mg कम हो गया तो डेल्टा भी कम हो जाएगा. तो इस फॉर्मूला के अंदर G दिखता जरूर है, लेकिन अगर आप बोलो कि मून के ऊपर जो G है वो अर्थ से 1/6 है, 1/6, then what will be the omega n? You will say it will remain same. Why? Because delta also accordingly changes. तो ये हमारे पास बेसिकली फॉर्मूला आ गया स्प्रिंग मास सिस्टम का. अब इसमें हम लोगों ने एक फॉर्मूला इसमें ऐड जो नहीं किया, वो स्प्रिंग का मास ऐड नहीं किया. अगर हम स्प्रिंग के मास को भी ले लें, लेट्स से स्प्रिंग का मास इज m डैश, तो यही फॉर्मूला हमारे पास हो जाएगा k ओवर m प्लस m डैश बाई 3 अंडर रूट, k ओवर m प्लस m डैश बाई 3 अंडर रूट. लेकिन मेरे को नहीं लगता यहां से कभी एग्जाम में क्वेश्चन वो पूछेगा, ना उसको पूछना चाहिए. अगर मैं स्प्रिंग का मास भी दे दूं और ये मास भी दे दूं, तो नेचुरल फ्रीक्वेंसी क्या होगी? आपने स्प्रिंग का मास डिवाइडेड बाय 1/3 को इस स्टैटिक मास के साथ जोड़ना है, एंड दैट फॉर्मूला यू आर टू यूज. तो स्प्रिंग मास सिस्टम में दिस इज हाउ क्वेश्चंस कैन बी आस्क्ड. नाउ लेट मी गिव यू वन मोर फॉर्मूला हियर. This formula we need to understand. This next formula. अगर मैं तुम्हें एक स्ट्रिंग दे दूं, स्ट्रिंग के साथ मास अटैच कर दूं, और अब उसने स्ट्रिंग का तुम्हें क्या क्या दे दिया भाई? रॉड या स्ट्रिंग उसने तुम्हें दे दी, ये मास है. रॉड या स्ट्रिंग दे दी जिसका उसने मॉडुलस ऑफ इलास्टिसिटी दे दिया. दिस इज मॉडुलस ऑफ इलास्टिसिटी, मॉडुलस ऑफ इलास्टिसिटी, राइट? ए इज द क्रॉस सेक्शन एरिया, ए इज द क्रॉस सेक्शन एरिया, राइट? मास इसका उसने कंसिडर नहीं किया. मास इज नॉट बीइंग कंसिडर्ड. मास जो अटैच है वही कंसिडर किया. अंडरस्टैंड? लेंथ इसकी उसने आपको L दे दी. L इज द लेंथ, राइट? L इज द लेंथ. दिस इज द लेंथ. इसका नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन निकालो. लेट्स सी व्हाट इज द स्ट्रेस. स्ट्रेस इज अ फोर्स पर यूनिट एरिया. व्हाट इज द स्ट्रेस इंड्यूस्ड? वेट पर यूनिट एरिया. वेट कितना लगा है इसमें? mg लगा है. ओके, व्हाट इज द स्ट्रेन? स्ट्रेन इज द स्टैटिक डिफ्लेक्शन पर यूनिट लेंथ. ओके, गुड. अब कैन यू टेल मी व्हाट इज मॉडुलस ऑफ इलास्टिसिटी? यस सर, सिग्मा बाई एप्सिलॉन. ओके, गुड. mg ओवर mgl ओवर डेल्टा इनटू a, if I'm not wrong. Okay, good. Can I say this is equal to ml over a into g by delta? Yes, I can say that also. What I want to calculate? Natural frequency. Natural frequency is g over delta under root. Okay, can you write g over delta? Sir, this is ea over m into l under root. ea over ml under root. Now, what is ea? This e into a is called actually axial rigidity. एक्सियल रिजिडिटी. ये कहां पे किया तुमने? स्ट्रेंथ ऑफ मटेरियल में किया है. मेरे को नहीं लगता है यहां से भी वो क्वेश्चन पूछेगा, लेकिन यस इंपॉर्टेंट है, इंपॉर्टेंट है क्योंकि कोई डिफिकल्ट नहीं है इसमें, राइट। हमें जी ओवर डेल्टा निकालना था, ये देखो जी ओवर डेल्टा, जी ओवर डेल्टा उस फॉर्मूला से भी निकल जाएगा। तो जी ओवर डेल्टा कैसे निकाला हमने, हमने जी ओवर डेल्टा इस तरीके से निकाल दिया। अगर मॉडुलस ऑफ इलास्टिसिटी दे रखा है, जो स्ट्रेस ओवर स्ट्रेन है, स्ट्रेस क्या है, लोड पर यूनिट एरिया है, स्ट्रेन क्या है, डिफ्लेक्शन जितना प्रोड्यूस हुआ ओवर ओरिजिनल लेंथ है, इन्हीं को मैनिपुलेट करो, वहां से जी ओवर डेल्टा निकाल लो, तो ई ए ओवर एम एल आ जाएगा, ई ए ओवर एम एल अंडर रूट। अगर अब वो तुम्हें इसका मास, इस स्ट्रिंग का भी मास निकालने को मास देता है, तो अगेन m की जगह m डैश बाई 3 ऐड कर दो, लेकिन मेरे को लगता नहीं वो आएगा। हाँ, इतना पार्ट वो तुमसे पूछ सकता है, स्ट्रिंग है, उसका एरिया है, उसका मॉडुलस ऑफ वेलोसिटी है और लेंथ है, दैट पार्ट ही कैन गिव यू, राइट। सो स्ट्रिंग का अगेन ऑसिलेशन इज गोइंग टू बी लाइक दिस, अगेन लॉन्गिट्यूडनल वाइब्रेशन, राइट। थर्ड केस जहां से आता है फ्लोटिंग बॉडी, थर्ड केस जहां से क्वेश्चन आता है दैट इज floating body. You know there is a concept called floating body, and this body is oscillating like this, floating body. I tell you the principle of fluid mechanics here. I am to find out natural frequency of vibration of the floating body. You know what is the fluid principle here? Let us say the mass of this body is m. Let us say in the beginning इतने लेंथ तक ये डूबा हुआ है, इन द बिगिनिंग ये इस एल लेंथ तक, एल लेंथ छोड़ो, एल तो मैं टोटल लेंथ ले लेता हूं, लेट्स से इन द बिगिनिंग ये वाई लेंथ तक डूबा हुआ है एंड टोटल लेंथ इज एल, लेट्स से दैट टोटल लेंथ इज एल एंड टोटल लेंथ तक ये डूबा हुआ है। सो कैन यू टेल मी द buoyancy force acting on this body? Yes, buoyancy force is equal to, let's say the density of the liquid is rho naught, density of the liquid is rho naught, density of the liquid into volume, volume is y into cross section area is a, weight of the liquid displaced, weight of the liquid displaced कितना है, volume of liquid displaced y into area into density of the liquid, mass of the liquid displaced into g, वो किसके बराबर है, वो सर इसके वेट के बराबर है बॉडी के, क्योंकि बॉडी के वेट को कौन बैलेंस कर रहा है, buoyancy force. Listen carefully again. He may not give you mass of the body. So mass of the total body is m. So what is the weight of the body? Mg. What is the buoyancy force? Weight of the liquid displaced. What is weight of the liquid displaced? Volume of liquid displaced into density of the liquid into g. That is how we calculate it. This is buoyancy force and it balances the weight of the body. Now what happened? This is the equilibrium state. Now what happened? I pushed it and push करने से क्या हुआ, ये x डिस्टेंस और नीचे चला गया, ये x डिस्टेंस मैंने इसको पुश कर दिया नीचे की तरफ. सो आई एम पुशिंग इट नाउ बाय स्मॉल डिस्टेंस x from its mean position. Let me make some diagram here. Let me create some space here. What I did now, I pushed it x distance further. I pushed it by distance x from its mean position. From its mean position, I am pushing it by distance x. Now this is the additional depth. I pushed it. मैंने उसके ऊपर फोर्स लगाई. फोर्स लगाने से मैंने इसको नीचे पुश किया. And you know what? Now what is the restoring force? What is the restoring force? Let us say मैंने इसको नीचे की तरफ पुश किया and this is m into x double dot. What is mx double dot? फोर्स जो ऊपर की तरफ वापस जाएगा वो रिस्टोरिंग, यू नो हमने किया तो है अभी, m into a इज ऑलवेज अपोजिट टू x, x नीचे की तरफ तो एक्सेलरेशन ऊपर की तरफ. नाउ दिस मास ऑफ द बॉडी x डबल डॉट, राइट, प्लस व्हाट इज द रिस्टोरिंग फोर्स? रिस्टोरिंग फोर्स वहां पे स्प्रिंग में रिस्टोरिंग फोर्स क्या थी? लेट मी मेक द एनालॉजी हियर. सी द स्प्रिंग केस नाउ. लेट मी गिव यू द स्प्रिंग केस हियर. ओके, आई थिंक आई हैव मेड स्प्रिंग केस हियर. या मैंने स्प्रिंग को x डिस्टेंस नीचे मूव किया, उसके ऊपर रिस्टोरिंग फोर्स कितना लगा? kx, mx डबल डॉट पीछे की तरफ. अब जब बॉडी फ्लोट कर रही है तो उस फ्लोटिंग बॉडी के ऊपर जो रिस्टोरिंग फोर्स है वो एडिशनल buoyancy फोर्स है. एडिशनल buoyancy फोर्स कितना है? कॉरेस्पॉन्डिंग टू x. ओके, रो नॉट इंटू x इंटू a इंटू g इज इक्वल टू 0. ओके, गुड. So let me write this way, x double dot plus rho naught ag over m into x is equal to 0. Now can I calculate what is m over rho naught ag या rho naught a into g over m? यहां से तुम देखोगे तो this term rho naught a into g by m is nothing but this G gets cancelled out. I think this G terms gets cancelled out from here, and I have a term here which term will be equal to rho naught into this particular thing can be calculated in terms of Y. Just put the value of rho naught AG in terms of M, that is this rho naught AG gets cancelled out, rho naught into A into G gets cancelled out. Let me give it with M. And I can write this very thing in terms of Y and G. I can write this in terms of Y and G. And Y and G, I can write this X double dot plus this rho naught into A into G gets cancelled out over M. This term gives me, I mean, rho naught AG by capital M. This gives me G over Y. So this is G over Y into X. And you know what? From here, I calculate what is the natural frequency of vibration. That is how we analyze it. Natural frequency of vibration is rho AG over M, or you can without, I think I'll go to next part. Let me not create, because notes are to be made. So what is the natural frequency we get here? Okay, so what I get is X double dot plus rho AG over M, rho AG by M. So X double dot plus rho AG by M, X is equal to 0. So natural frequency is rho naught AG by M under root. This is the natural frequency of vibration. Now, from where we shall calculate rho naught AG by M? From this equation. So corresponding to Y, you can calculate this particular value and put that value and you can calculate it. So that will give me natural frequency of vibration of the floating system. So, in a longitudinal vibration, question is asked from three places. One is spring mass system, another is a string mass system, third is floating body system. Only three cases. And very, very simple case. Remember that mass of the body he will not give you. That mass is to be calculated in terms of initially how much that is sink part. Y की term में आपको निकालना पड़ेगा. इस तरीके से आप निकालेंगे rho naught AY into G. Let me again give you rho naught AY into G, that is equal to capital M. So you will basically, in place of M, you are going to put this value here, and in terms of Y, you can calculate natural frequency of vibration. Okay, now let me go to second part. Second part for us is now the transverse vibration. So what is the transverse vibration? That is the next part. Very, very simple. And I told you this transverse vibration mein, I told you, suppose I give you a beam, and this is what is the two main important points here: simply supported beam and cantilever. Simply supported beam and cantilever. Now let us say I'm giving you simply supported beam and cantilever, and in that simply supported beam and cantilever I'm giving you some kind of loading which is applied. Let us say here the load applied is W, which is mg. Let us say length is L. Can you tell me what is the deflection produced? Or for that matter, what is deflection produced here if I apply load W is equal to mg? In strength of material, we know this particular formula. All we need to know is natural frequency of vibration is G by delta. So what is delta? Delta is the load applied under the weight. Now let's say this is A, this is B. I'm going to give you general formula, and in this particular case delta is equal to W A square B square divided by 3EIL. L is the total length, I is the moment of inertia of this beam, and E is the modulus of velocity of this beam. Similarly, this delta in this case is equal to, let me give this formula, WL cube over 3EI. For cantilever, this is the value of delta for cantilever. And if I give you a fixed beam, let us say this is a fixed beam, I give you, and there is a load W, let us say this is A, this is B. Then under this load, what will be the value of delta? That will be equal to W A cube B cube over 3EIL क्यूब. ये फॉर्मूला थोड़े से आपको डेल्टा के याद रखने हैं, डिफ्लेक्शन के फॉर्मूले याद रखने हैं इन ट्रांसवर्स वाइब्रेशन. एंड एग्जाम में क्वेश्चन आता है, यहां से भी क्वेश्चन आता है, कैंटिलीवर है, एक लोड लगा हुआ है, डिफ्लेक्शन इज डेल्टा. द मोमेंट यू कैलकुलेट डेल्टा, देन नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन इज G over delta under root. That's it. Transverse vibration में these are the formulas which you need to calculate, and they are very very simple formula. So he might give you some kind of beam deflection, you have to calculate strength of material and mechanical vibration का combined question. But you know, in this particular part transverse vibration में the question he normally ask is from whirling of shaft, because shaft is rotating and because of unbalanced mass there is a whirling of the shaft produced. वहां से क्वेश्चन वो निकालता है. लेकिन whirling of the shaft मैं आपको करवाऊंगा जब फोर्स्ड वाइब्रेशन आएगी, बिकॉज फोर्स्ड वाइब्रेशन में रेजोनेंस का कंसेप्ट है. तो द मोमेंट आई कम टू फोर्स्ड वाइब्रेशन, आई एम गोइंग टू डिस्कस विद यू whirling of the shaft होता क्या है. That particular case today I am discussing only undamped vibration. That is the reason I am not going to talk about whirling of the shaft. Now third part which is we have to do today, that is basically the torsional vibration. अब मैं तीसरा पार्ट torsional vibration करता हूं, and then we go for questions of this part, torsional vibration. अभी torsional vibration में सबसे important जो part है which we have to do, that is a pendulum. You know, I am giving you this pendulum. अब क्या होता है, मैं इस पेंडुलम को उसकी मीन पोजीशन से डिसलोकेट करता हूं बाय थीटा. लेट्स से लेंथ इज एल, राइट. नाउ दिस mg हैज टू कंपोनेंट्स. एक तो mg cos थीटा जो टेंशन क्रिएट करता है, और एक mg sin थीटा जो इसको इसकी ओरिजिनल पोजीशन पे वापस लेके आता है. तो थिंक ऑफ स्प्रिंग. स्प्रिंग में विच फोर्स वाज ब्रिंगिंग द स्प्रिंग बैक? The force was spring force, that is the k into x. In buoyancy floating body, which force was bringing it back? Buoyancy, additional buoyancy force, right? In case of pendulum, this component mg sin theta is bringing it back. Now अगर मैं linear motion and rotational motion को analogy लूं, लीनियर मोशन एंड रोटेशनल मोशन का मैं अगर एनालॉजी लूं तो कैसा एनालॉजी बनेगा? देखो यहां पे मास, यहां मूवमेंट ऑफ इनर्शिया विच इज मास इनटू रेडियस ऑफ जायरेशन स्क्वायर, राइट. यहां पे थीटा, यहां पे सॉरी डिस्प्लेसमेंट, तो यहां पे थीटा, यहां पे वेलोसिटी, यहां पे ओमेगा, यहां पे एक्सेलरेशन, तो यहां पे अल्फा की हम बात करते हैं, राइट. दिस हाउ वी टॉक अबाउट. नाउ अगर मैं बोलता हूं यहां पे इक्वेशन आती है एम एक्स डबल डॉट प्लस के एक्स इज इक्वल टू 0, राइट. तो यहां पे बात आएगी आई थीटा डबल डॉट प्लस क्यू इंटू थीटा इज इक्वल टू 0. अब ये के क्या है? स्टिफनेस है. तो क्यू क्या है? ये टॉर्शनल स्टिफनेस है. क्यू क्या है? वो टॉर्शनल स्टिफनेस है. मींस अगर मैंने बॉडी को उसकी मीन पोजीशन से डिस्प्लेस किया तो बॉडी उसकी मीन पोजीशन की तरफ वापस आने की ट्राई करेगी. देयर विल बी थीटा डबल डॉट एम एक्स डबल डॉट. रिमेंबर जब स्प्रिंग को मैंने उसकी मीन पोजीशन से हटाया था, आई सेड एम एक्स डबल डॉट विल बी द रिस्टोरिंग फोर्स. यहां पे रिस्टोरिंग टॉर्क विल बी आई थीटा डबल डॉट. वहां पे स्प्रिंग फोर्स उसको वापस लेके आया था, यहां पे रिस्टोरिंग टॉर्क होनी चाहिए. व्हाट इज दैट रिस्टोरिंग टॉर्क? दैट रिस्टोरिंग टॉर्क इज mg sin theta. See carefully, mg sin theta into the length of the spring, length of this particular pendulum. This force is producing a movement at point O. How much movement this is producing? mg sin theta into L, that is bringing it back. अब अगर मैं इस चीज का इक्वेशन बनाऊं तो ये बनेगा, that means theta double dot plus mg into L over I into sin theta is equal to 0. And I tell you one thing, oscillation and vibration में क्या difference है? Sir, that oscillation in which amplitude of vibration is very small, that oscillation in which amplitude from the mean position or the displacement from mean position is very small, is called vibration. That means theta is very small. And if theta is very small, sine theta is almost equal to theta. So this very thing can be compared as theta double dot plus mgl over I. I is the moment of inertia about which? I is the moment of inertia about which? Okay, I don't know what has happened. Okay, so this I is to be taken about not this point O. And I will tell you how moment of inertia is to be calculated. Into theta is equal to 0. So what is the natural frequency of vibration? What is the natural frequency of vibration? Omega n is equal to mgl over I naught under root. I naught is the moment of inertia of this entire system about point O. अब इस पूरे सिस्टम में अगर only तुम्हारा मास ये आया है, only point मास है, इसके मास को मैं कंसिडर नहीं कर रहा हूं. अगर मैं इसके मास को कंसिडर नहीं कर रहा हूं, then there is no trouble. But अगर मैं इसके मास को कंसिडर कर रहा हूं, then I naught is to be accordingly calculated. So let me go one step forward and again see this. मैंने अब क्या कर दिया, ये मेरे पास स्प्रिंग मास सिस्टम था, ये मेरे पास सॉरी पेंडुलम सिस्टम था. अब अगर मैं इसके सारे मास को लूं, लेट से मास ऑफ रॉड को भी लूं, तो मास ऑफ रॉड का भी एक कंपोनेंट बनेगा. यू नो, दिस इज मास m, दिस इज एम आर, दिस इज थीटा, दिस कंपोनेंट इज एम आर साइन थीटा, this component is mr into g into sin theta, and this one is mg sin theta. Understand? So what is the equation now? Sir, equation is, let us say this is not. This equation now is, what are the restoring forces? I theta naught, I naught into theta double dot, that is restoring inertia, m into a. And what again, what other forces? mg sin theta into L. Good. And how much is this distance? This centroid of this rod mass is at L by 2. So then this will be mrg sin theta into L by 2. So क्या इक्वेशन बन जाएगा हमारे पास? हम बोलेंगे सर I naught into theta double dot plus mg sin theta, this mg sin theta into L plus mr into g into sin theta into L by 2, that is equal to 0. Understand? This is how it is to be. And ये कौन सा हम concept use कर रहे हैं, हम कौन सा method use कर रहे हैं? Using the equilibrium method, because net movement is 0 now. So net movement produced at point O will be 0. Net force or net movement is equal to 0. अब अगर इसको तुम थीटा बहुत छोटा कर दो, this very formula will become theta double dot plus mgl plus mrgl by 2 divided by I naught into theta is equal to 0. So what is now omega n? Omega n is, sir, m plus mr by 2 over I naught into GL under root. And how do we calculate I naught? Moment of inertia about point O. What is moment of inertia about point O? Sir, this mass will have moment of inertia ml square, point mass, distance L, and rod about one of its ends. Mr is a rod, mr L square by 3. You know, the moment of inertia of the rod of mass mr about one of its ends is ml square by 3. That also I'm going to give you that particular formula. This is how we calculate this particular thing. So this is the moment of inertia of this entire system. We can calculate this moment of inertia of this particular system. Now this, if we put value of this, then certain things will get cancelled out, and you know, L square will get cancelled out. This entire formula will come out to be m plus mr by 2 over m plus mr by 3 into g under root. This is the formula. But suppose I do not consider the value of mass of rod, then if I do not consider mass of rod, yes, this is gl square, this will be g over L, because one L will get cancelled out, one L will remain. So if mass of the rod is not considered, then omega n will be g over L under root. And now listen carefully. What is the natural frequency of vibration of a pendulum? Think of, you are considering only the mass of the bob. This particular thing is called bob. or you are considering the mass of rod also. If you are only considering mass of the bob, this is the formula. If you are considering the mass of the rod, this is the formula. Now, if I take pendulum to the moon, is it going to change its natural frequency of vibration? Answer is yes. Why? Because now G is going to change, L is not going to change. Spring mass system, if I take on the moon, is it going to change the natural frequency? Answer is no. If pendulum I take on the moon, is it going to change the natural frequency? Answer is it is not going to change the natural frequency of vibration for pendulum, but it is going to change the natural frequency for basically it is going to change the natural frequency for pendulum, but it is not going to change the natural frequency for spring mass system. Pendulum may G is going to change, hence natural frequency is going to get changed. Spring mass system may both G and delta are going to change, hence natural frequency of vibration is going to get changed. So this is the way of calculation of torsional vibration. I think this is how we go for torsional vibration. Some small part again I discuss with you, and that is this. Let me give you this small system here, and this small system is connected with the spring. Understand? And this is a roller. Let us say this is a roller. This is the K, stiffness K, right? Now, suppose I oscillate it about point C by small distance theta. मैंने उसको मेन पोजीशन से इस तरफ को डिसलोकेट किया, तो बता सकते हैं ये कितना डिस्टेंस स्प्रिंग में कंप्रेशन आएगा. रेडियस इज आर, तो x इज इक्वल टू r इंटू थीटा. x इज इक्वल टू r इंटू थीटा. ट्राई टू अंडरस्टैंड, दिस इज वेरी वेरी इंपॉर्टेंट केस. मैंने एक डिस्क लिया, एक रोलर लिया, और उस रोलर को मैंने स्प्रिंग के साथ अटैच किया और मैंने उसकी मेन पोजीशन से थीटा डिसलोकेट कर दिया. तो अगर मैंने थीटा डिसलोकेट किया तो स्प्रिंग में कितना कंप्रेशन आया, दैट इज x, एंड x इज इक्वल टू r थीटा. r इज द रेडियस, राइट? अच्छा, स्प्रिंग में अगर कंप्रेशन आया तो भाई स्प्रिंग फोर्स लगाएगा. वो कितनी फोर्स लगाएगा? kx फोर्स लगाएगा, और वो फोर्स यहां पे लगेगी, ऐसे लगेगी फोर्स, राइट? अब रिस्टोरिंग टॉर्क्स कौन कौन सी हैं? एक तो I अबाउट C पॉइंट, इस पॉइंट पे, क्योंकि दिस इज द पॉइंट ऑफ ऑसिलेशन. नाउ about this point, what is the moment of inertia of rotor? Spring का mass I am not considering. तो IC into theta double dot, ये जो हमने inertial discuss किया torsion, right? IC moment of inertia of the rotor about C into theta double dot, right? Plus ये जो आपकी spring force है, ये भी तो restoring torque लगाएगा. Spring force कितनी restoring torque लगाएगा? F into R. What is F? F is spring force. What is spring force? This is K into X. Understand? What is X? Sir, K into R theta. Okay? तो अभी कितना restoring torque लेगा? FR. तो क्या इक्वेशन बना? IC theta double dot plus FR is equal to 0. Theta double dot plus FR is what? KR square theta over IC is equal to 0. And what is IC? IC is the moment of inertia of the rotor about point C. तो आपको पहले देखना पड़ेगा रोटर है क्या, डिस्क है, रोलर है, क्या है, उसका मोमेंट ऑफ इनर्शिया अबाउट सेंट्रॉयड O निकालना पड़ेगा, फिर पैरेलल एक्सिस थ्योरम यूज करके इस पॉइंट पे निकालना पड़ेगा. तो हमारे पास ओमेगा एन कितना आ गया? सर ओमेगा एन इज के आर स्क्वायर ओवर आई सी अंडर रूट. दैट इज हाउ वी कैलकुलेट इट. Now, I will give you two very, very small things here. Number one, how to find out moment of inertia of the bodies. Remember, if it is a disc or solid cylinder, radius R, mass M, then it is mr square by 2. Solid cylinder या disc mr square by 2. About point O, centroid. अगर मेरे पास सॉलिड स्फीयर है, इफ आई हैव सॉलिड स्फीयर, तो 2 by 5 mr स्क्वायर. अगर हॉलो स्फीयर है देन 2 by 3 mr स्क्वायर. ओके, डन. अगर मेरे पास रॉड है और वो रॉड का मोमेंट ऑफ इनर्शिया अबाउट सेंट्रॉयड निकालना है, तो ml स्क्वायर by 12. रॉड ऑफ लेंथ L, मास M. About one of the ends is ml square by 3. If there is a rod, moment of inertia of the rod about centroid is ml square by 12. Moment of inertia of the rod about one of the ends is ml square by 3. Now, if I give you annular ring, that means there is a ring of mass m with radius r1 square r2 square. Then this is m r1 square plus r2 square by 2. This is the moment of inertia of the ring, that is the annular ring. Understand? M r1 square plus r2 square by 2. So solid sphere, hollow sphere, solid cylinder or disc, or he can give you ring. I have not taken example of ring. Ring means hollow cylinder, that is mr square. These are the formulas you need to remember for this chapter. What are the formulas of moment of inertia? Solid sphere, hollow sphere, disc, ring, annular ring, rod. These are the only formula. And as you know, if there's a point mass, then it is m into l square. L is the distance from where it is rotating. And you know what? There's a parallel axis theorem. Parallel axis theorem says that if you already know moment of inertia about point O and you want to find out moment of inertia about point C, then what you have to do is, parallel axis theorem says moment of inertia about point C is the moment of inertia about point O, centroid, plus m into x square. M is the mass of this body, x is the distance between these two parallel lines. Like moment of inertia about this, if it is a disk, is mr square by 2, but about this is mr square by 2 plus mr square, that is 3 by 2 mr square. Last thing before we go for questions is stiffness. Remember that if I attach the springs of stiffness K1 and K2 in a series, or let me see if I find some space somewhere so that I can write it initially where there was a space. Spring stiffness I will do. So if I give you two springs of stiffness, let's say K1 and K2, and I attach these springs in parallel, so parallel mein stiffness is K1 plus K2. But if I attach the springs in series, let's say K1 K2 is the stiffness, 1 by Ks is 1 by K1 plus 1 by K2, 1 by K1 plus 1 by K2. Okay, so you know, as far as the formulas are concerned, I think what we have done today, what we have done so far in the formulas, I'm going to do questions also. I have just summarized all the formulas and concepts in mechanical vibration for undamped, without damping, undamped vibration. स्प्रिंग का क्वेश्चन आएगा, फ्लोटिंग का क्वेश्चन आएगा, टॉर्शनल वाइब्रेशन आएगा, ट्रांसवर्स वाइब्रेशन आएगा. Let's go for some questions and try to find out how to solve these questions. I'm going to send this entire document to you. जो भी मैंने लिखा, वीडियो सुनना और इस डॉक्यूमेंट को रिवाइज करना. And then 20 questions I've already sent you. Let me hit some questions here, and I think we can go forward with those particular questions now. Okay, so I want to save it. Yes, as a okay. So I've saved this data here, and I'm going to send you this data soon. Okay, so I can take some questions. नहीं, एनुलर रिंग में माइनस नहीं आएगा. आई थिंक आई कैन आंसर सम ऑफ योर क्वेश्चंस जो आपने शूट किए हैं. लेट मी गिव योर क्वेश्चंस नाउ. 1/3 m plus m by 3 q. That answer is in derivation. You need to derive it, then only you can find that. So that only you will get to know from derivation. Your second question was sin theta. If theta is very small, why sin theta is equal to theta? Think this way. If theta is 0, what is sin 0? 0. If theta is 90 degree, what is sin? 1. If theta is 0, what is cos 0? Cos 0 is 1. So if theta is 0, sin theta is also 0. That means sin theta is almost equal to theta. Theta 0 means very, very small value. Think of this way. This is not a very good way to explain, but yes, you will understand. If theta approaches 0, theta is very small. then sine theta is equal to theta. Both are 0. Same tan theta also. Okay, then you said annular ring में minus नहीं आता. नहीं, annular ring का मैंने formula बताया, mr1 square plus r2 square over 2. This is the moment of inertia of the annular ring. Now let me give you this annular ring. This is r1, this is r2, and the mass is m, right? If r1 is equal to r2, तो I कितना हो जाएगा? mr square. r1 is equal to r2 put करो. r1 is equal to r2 means ring बन जाएगी वो, right? But if r1 is equal to 0, that means वो solid disk बन जाएगी. r1 कम हो गया, solid disk बन जाएगी. तो I का फॉर्मूला क्या आ जाएगा? mr square by 2. तो ये दोनों फॉर्मूले रिंग के और सॉलिड सिलेंडर या डिस्क के फॉर्मूला इसी से निकल जाता है. बट दिस इज अ वेरी वेरी इंपॉर्टेंट फॉर्मूला. Moment of inertia of annular ring. Annular ring means mass is concentrated for the ring between radius r1 and r2. If r1 is equal to r2, entire mass is concentrated at periphery. Then this becomes formula of mr square by 2. But if r1 is 0, that means uniformly distributed mass. Then this formula becomes mr square by 2. This is how this becomes. Are we ready to go for questions now? Yes. Let me give you first question here. Now he has given you a spring. First question I am taking with you. He has given you, there is a spring which deflects. He has given you a spring. Try to understand. Those of you who do not have this question, I have sent it, but do not have. This is the free length. He has given you a free length like this. Then you know what happens is, on the free length, he puts some mass, something like this. And he says that when I put mass on the free length, the deflection produced is a delta. You know, when I put mass m on the free length, deflection produced is a delta, right? And this position, equilibrium position, he called it as A position. Now this is equilibrium position A. Now during free vibration, the body reaches a position B. During free vibration, now the vibration started, and the body reaches position B. Now this is the B position. He says, what is the change in potential energy of the spring mass system from position A to position B? What is the change in potential energy of spring mass system from position A to position B? And he has given you some kind of basically answers also, some kind of choices also he has given you. Now, how to solve this particular question? I tell you, there are two kinds of basically potential energies. There are two kinds of potential energy. One is gravitational potential energy, and another is elastic potential energy. It is related to mgh and it is related to half of kx square. Now, spring does not have mass. Spring does not have mass. So can you tell me, in the free length, what is the elastic potential energy of the spring? Answer is nothing. It is 0. Okay. This is the mass. Compared to this position, when I lower it down, compared to this position of the mass, when I lower it down, its potential energy decreases by mgx. This can become the reference for me to calculate the potential energy. This can become reference for me to calculate potential energy. Now, what kind of energy spring has here and what kind of energy spring has here? That is what you have to see. Now, when I compare these two things, when I compare the energies in these two A and B position, I can take difference of the energies of the spring, potential energy of the spring at point A, potential energy of the spring at point B. I can compare it and I can calculate it. Okay, now I take point B as a reference for gravitational potential energy. This is taken as a reference for gravitational potential energy. I assume that gravitational potential energy here is 0. I assume gravitational potential energy here is 0. And I take it as reference for elastic potential energy. Elastic potential energy of the spring. What is the elastic potential energy of the spring in the free length position? 0. What is the gravitational potential energy of the mass here? That is also 0. Now, Can you tell me what is the total potential energy at point A? What is the total potential energy at point A? Now, potential energy at point A. See, the question is, what is the change in potential energy of spring mass system between A and B? Can you tell me what are the potential energy of spring mass system at point A? Mass is x meter above, so mg into x. Mass कितना ऊपर चला गया है यहाँ पे mgx. What is the gravitational potential energy of mass here? mgx. Why? Gravitational potential energy of the mass here is 0. तो यहाँ पे कितना हो गया gravitational potential energy of the mass? mgx. Okay, done. And spring का इलास्टिक पोटेंशियल एनर्जी here is 0. एंड स्प्रिंग का इलास्टिक पोटेंशियल एनर्जी यहां पे कितना हुआ? तुमने डेल्टा कंप्रेस किया उसको, हाफ ऑफ k delta square, half of k into delta square. Good. Now, what is the potential energy at point B? What is the gravitational potential energy of the mass at point this? Nothing, 0. But what is the elastic potential energy of the spring? Elastic potential energy of the spring is half of k delta plus x whole square. With respect to this, now what is the total compression produced in the spring? Sir, that is delta plus x. Delta plus x, that is the total compression produced in the spring. So this is half of k into delta plus x whole square. Now what is the difference in potential energy? You have to find out now difference in the potential energy between these two positions. And remember one thing here, you are to remember one thing here, like this, when you go from this position to this position, then yes, this mg is equal to k into delta. So mg compresses it, mg is equal to k into delta. So let's try to find the difference between the two potential energy between B and A. So this is half of k delta plus x whole square minus mgx plus half of k delta whole square. Just open it out. Half of k delta square plus half of k x square plus k delta into x. You understand? K into delta into x minus mgx minus half of k delta square. Certain things will get cancelled out. This thing will get cancelled out, right? And see this now, k delta x minus mgx. As I told you, in this particular case, first to second, mg is equal to k delta. Mg is equal to k delta. So mgx and k delta x gets cancelled out. Understand this? So answer is half of kx square. So answer will come half of kx square. And there was no need to calculate this also. There was no need to calculate this also. If you compare between this position and this position, also you could have calculated what is the total potential energy, elastic potential energy, and here also total potential energy. You could have compared and calculated the difference also. So that directly also you could have obtained. But yes, this mg weight is equal to k into delta. That is the free body diagram of this system will give you that mg is equal to k delta. Static deflection, just now we did mg is equal to k delta. Put mg is equal to k delta here, and that is how you can calculate it. So very good question, that what is the potential energy difference between spring mass system. So what kind of two potential energies we have? In the mass there is a gravitational potential energy, and in the spring there is a elastic potential energy. And this question is a very, very good question, on the basis of which we can calculate basically the difference of the energies. Okay, should I give you now similar question to this? For an underdamped harmonic oscillator, what is resonance? Resonance वाला question हम लोग कल करेंगे. I will do resonance वाला question with you tomorrow. Let me go for question number 3 now. Question number 3 is natural frequency of spring mass system on earth is omega n. Spring mass system, you know, he has given you spring mass system, k, this is m, so omega is k over m under root, that is equal to g over delta under root. We have seen that, right? Why? Because mg is equal to k into delta, so k over m is equal to g over delta. So g over delta, delta is a static deflection, just now we saw it. Now it says the natural frequency of the system on moon, and it says moon के ऊपर acceleration due to gravity is earth की acceleration due to gravity divided by 6. So what is the natural frequency of this system on surface of moon? Answer is it will remain same. So omega n will remain g by delta only. Why? Because if acceleration due to gravity on the surface of moon changes, delta also on surface of moon changes. Both are balanced, but that will not be same for pendulum. Next year, this year, he might ask you question of the pendulum. That एक pendulum है और मैं उसको moon के ऊपर ले गया. So बताओ उसका natural frequency कितना change होगा? G over L. So the same question if I give you for let's say now pendulum. This is the length of the pendulum. This is the mass of the bob. I take it on the surface of moon. Omega n आपने बोला G by L under root. Understand? This is the formula you made. I take it on the surface of moon. What will be the natural frequency on moon? Natural frequency of the moon will be now G over 6L under root. Why? Because yes, it depends upon the surface of the moon now. क्योंकि L तो चेंज नहीं हो रहा, लेकिन G तो 1/6 हो गया, तो मून के सरफेस पे ये चेंज हो जाएगा. तो अगर तुम घड़ी यूज कर रहे हो यार, तो तुम्हें ये वाली ले जानी चाहिए, ये वाली घड़ी ले जानी चाहिए. आई आस्क दैट क्वेश्चन टू यू, आंसर इट इन योर विजडम. मेरे को कौन सी घड़ी ले जानी चाहिए? तो ये पेंडुलम वाला केस है. पेंडुलम में नेचुरल फ्रीक्वेंसी मून पे चेंज होती है, और ये स्प्रिंग मास सिस्टम है. स्प्रिंग मास सिस्टम में चेंज नहीं होती है. दिस इज समथिंग विच यू आर टू कीप इन योर माइंड. ओके, okay, so if you are in third year and if you are saying should we watch these videos, see, this is not crash course going on. Entire mechanical vibration in 5 hours, and it will not be good for those of you जिन्होंने mechanical vibration पहले नहीं पढ़ा है. आपको कुछ पता नहीं चलेगा, आपको इसका benefit नहीं होगा. This is for those students who are in the revision mode, who have studied something, or even if they have not studied at all but exam is coming. So if you are in third year writing gate, पहले नहीं पढ़ा है, at least see this. एग्जाम निकलने के चांस हैं. जो नोट्स में दे रहा हूं, जो वीडियो में दे रहा हूं, उससे क्वेश्चन निकल जाएगा. एंड यहां पे ये जो क्रैश कोर्स चल रहा है, इसका पर्पज है फॉर देम हु कैन क्लियर दिस एग्जाम. एंड वंस यू क्लियर दिस एग्जाम, you know Yourpedia is the platform which will push you to IIT system and to the jobs. That is what is the entire purpose. So even if you clear this exam, then you stand a chance. That is the purpose, and that is the reason we are pushing it hard कि आपका clear हो जाए, and that is what we do it, right? Anyhow, now let's go to next. Now what question he has given is this: a static deflection of a spring under gravity. Okay. Static deflection of spring under gravity. Let me give this question number, I think is the fourth question for you. It is a static deflection is given to us. We are given the static deflection, and that static deflection is 1 millimeter, 1 mm. Mass is 1 kg. Static deflection of a spring under gravity when mass of 1 kg is suspended is 1 millimeter. So if acceleration due to gravity is 10 meter per second square, natural frequency of the spring mass system क्या होगा? G over delta under root. G कितना भाई? 10. delta कितना है? 10⁻³ तो कितना हो जाएगा? This is 100. Is it coming 100 radian per second? Yes, 100 radian per second. What was trouble in this question? It is a very, very simple question. And you know, if you ask me, sir, कितने simple question क्यों दे रहे हो आप? Why you are taking so simple? You know, GATE is a simple exam only. GATE is not a ticklish exam if you want to score up to one level. डरो मत, GATE is a very simple exam, and scoring up to a moderate value is also very, very easy, not difficult. Question number 5. Let me handle question number 5. This is what he has given you. This is what he has given you. You know, I will pick up the pace as I told you in engineering mechanics also. I told you GATE में easy question आते हैं 60%, 60 to 65% are very, very easy, something like this. Then 30%, next 20% will be moderate difficulty, 10-20% are very difficult. So if you want to score 80 plus, it may be difficult, very difficult. But if you want to score 60-50, it is not difficult. If you want to score, let's say 75, moderate difficulty में जाना पड़ेगा. Otherwise simple questions हैं, something like this. Mass is attached to two ideal springs having stiffness K. ऐसा K अटैच दिया है. नेचुरल फ्रीक्वेंसी कितना होगा, इन दोनों का निकालो ना, पहले इन दोनों का आप इक्विवेलेंट निकालो. दिस इज इन द पैरेलल. इफ इट इज इन द पैरेलल, व्हाट इज Kp? Kp इज 2K. व्हाट इज ओमेगा n? K by m. तो इंस्टेड ऑफ K just put 2K. I think this is 2K by m. That is the answer for that, right? Okay. Next question is also very simple question. The question number 6. What is question number 6? This is what he has given you. Question number 6 is, he is giving you these two systems, you know. He is giving you this system number 1, K. This is system 1. This is system 1. This is mass m. And then he gives you this as system. Right? This is K and K. And this is system M. System 1, system 2. System 1, system 2. What is the natural frequency ratio of this system and this system? So what is omega n? Omega 1 is, this is, if you take the natural frequency, it is K by 2. How? 1 by K plus 1 by K is 2 by K. So what is the series connection hai ye? And what is the natural frequency of this? It is 2K. Omega 1 is K by 2m. And omega 2 is 2K by m. And if I calculate omega 1 by omega 2, understand how much that is coming? K by 2m, 2K by m. Don't you think that is coming out to be, how much is that coming out to be? Take the ratio and tell me what is the answer for that. Okay, K by 2m and 2K by m. Km gets cancelled out, 1 by 2. So answer is 1 by 2. Ratio is 1 by 2. Right? Question number 7 and 8 are similar. Question number 7. This is given spring mass system. Understand? And he has given you K1, K2, K3. K1, K2, K3. And this is M. He is asking you natural frequency. You know, K1, K2, K3 are given 1, 3, 2. K1 is 1, 3, 2 kilonewton per meter. Can you tell me total stiffness? Okay. So Ks, this is Ks for this. That is K1, K2 over K1 plus K2. From where I got this formula? 1 by K1 plus 1 by K2 is K1 plus K2 over K1, K2. But that is 1 by Ks. So if there are two springs with the stiffness K1, K2 in series, remember this formula. Series का stiffness is K1, K2 over K1 plus K2. कितना हो गया? 3 over 4 kilonewton per meter. Okay, उसको K3 के साथ जोड़ दो तो टोटल K कितना आ गया? 3 by 4 plus 2, 11 by 4 kilonewton per meter. अब M कितना दे रखा है उसने? M is given as 1 kg. M is given as 1 kg. Can you calculate what is omega n? In radian per second omega n, that value is basically 52.4. 52.44 radian per second. That is a value we can think of getting, right? Okay, let's go for question number 8. Question number 8 is also pretty simple. I'm sorry, I cannot give you difficult question if only simple questions are being asked. So 20 kilonewton per meter, 20 kilonewton per meter, 100 kg. Understand? Mass is 100 kg. What is the natural frequency in cycle per second? So he is asking in hertz or cycle per second. This is parallel or series. Maximum student make the mistake by saying this is the series connection. अरे series नहीं है वो parallel connection है. Think of अगर तुम इसको ऊपर उठा के ले जाओ तो ऐसा नहीं दिखेगा क्या तुम्हें? अगर तुम दूसरे एंड को ऊपर उठा के ले जाओ तो तुम्हें ऐसा दिखेगा 100 kg. This is 20. This is also 20. What I did, I took and B को मैं ऊपर ले गया ऐसे उठा के, तो पैरेलल कनेक्शन है. पैरेलल कनेक्शन है तो कितना हो गया? 40 हो गया. तो ओमेगा एन इज बेसिकली K ओवर M. K कितना है? 40 इंटू 1000 किलो है ओवर 100 अंडर रूट. बट ही हैज आस्क्ड यू कैलकुलेट 1 by Fn. तो व्हाट इज Fn? Fn हमारे पास कितना आ जाएगा? 10 by pi. ये कितना हो गया? ये तो हो गया 20 राइट रेडियन पर सेकेंड. तो 1 by 20 नहीं 2 pi सॉरी omega n is 2 pi Fn. Understand? So Fn is equal to 10 by pi cycle per second. That was the question. Very, very simple question. Hardly anything in this question. Okay. Next question is 9th question is also very simple. This is the question given. This is the question given. Okay. K1 and this is K2. This is the question given to us. Now he is asking with the natural frequency of, what is the natural frequency of spring mass system which is given below? It is a frictionless. It is frictionless. Mass is M and the stiffness is given as K1, K2. Okay. Let me tell you one thing. In this case, whether the system is kept like this or the system is kept like inclined, answer is same. It is parallel. Is it not parallel? Right or not? K1, K2, K1, K2. This is mass. Understand? These two are in parallel. K1, K2. This is also parallel. Whether the system is kept on horizontal surface or the system is kept on inclined surface does not make any difference to the oscillation. You will say, लेकिन सर इस मास का एक कंपोनेंट mg sin theta ऐसे भी तो लगेगा. वो तो पहले ही लग चुका है. That already is acting. That is already producing the compression जो उसने करनी है. अब vibration is always with respect to equilibrium. Once the equilibrium is attained, in this case equilibrium is attained here. In this case equilibrium will be attained somewhere else. But after equilibrium, if you move it by distance x, if you move it by distance x, can you tell me what is the restoring force acting on this? K2x इस तरफ and K1x वो भी इसी तरफ, और इसमें K2x इस तरफ और K1x also this side. That means there is no difference in the analysis in this case and this case. तो क्या हो जाएगा natural frequency? Natural frequency of oscillation is K1 plus K2, that is total K over M under root. ऐसे आप natural frequency of oscillation निकाल सकते हैं. This is how natural frequency can be calculated. Okay, so 10th question is critical frequency or whirling frequency, जो मैं अभी नेक्स्ट क्लास में हम क्रिटिकल करेंगे एनालिसिस, तो उसमें हम उस चीज को निकालेंगे. क्रिटिकल फ्रीक्वेंसी हम उस केस में निकालेंगे. 11th क्वेश्चन इज गुड. सी द क्वेश्चन नंबर 11. Question number 11th is, a point mass is executing simple harmonic motion with amplitude given as 10 millimeter and frequency is given as 4 hertz. What is the maximum acceleration? What is the maximum value of acceleration in meter per second square? That is the question given to us. Maximum acceleration in meter per second square. Okay. What is x? A sine of omega n t plus phi. Okay. What is velocity? A omega n cos of omega n t plus phi. Okay. What is acceleration? A omega n square sine of omega n t plus phi. नेगेटिव साइन. अब एक्सेलरेशन का मैक्सिमम वैल्यू कितना होता है? दैट इज a इंटू ओमेगा एन स्क्वायर. ओके. अब ये ओमेगा एन नहीं दे रखा है, ये सॉरी एफ एन दे रखा है. यहां से ओमेगा एन कैसे निकलता है? ओमेगा एन इज 2 पाई इंटू एफ एन. तो कितना हो जाएगा ये? 8 पाई रेडियन पर सेकेंड. तो a कितना है? 10 इंटू 10 रेज टू पावर -3 मीटर में इंटू 64 पाई स्क्वायर. कैलकुलेट करो इसको, वैल्यू निकालो इसका. तो इसका वैल्यू हमारे पास आ जाएगा 6.32 मीटर पर सेकेंड स्क्वायर. That was the question. As I told you, he can ask you question from simple harmonic motion based upon this concept. He can ask you question from simple harmonic motion based upon this concept. He can do that. Very simple question can be asked from here. This is how simple question can be calculated. अभी अगला क्वेश्चन जो है वो पूछा गया है ट्रांसवर्स वाइब्रेशन से सिंपली सपोर्टेड बीम, जो मैं आपको बता रहा था. क्वेश्चन सुनना इसमें. क्वेश्चन नंबर 12 I do. Now listen this question carefully. There is a flexible rotor shaft system. 10 kg rotor disc is placed in the middle of massless shaft of diameter 30 millimeter and length 500 millimeter between the bearings. ऐसा है, ऐसा एक रोटर लगा हुआ है और शाफ्ट के ऊपर वो रोटर लगा हुआ है ऐसे. There is a rotor and this rotor flexible rotor shaft system having 10 kg rotor disc. This is a 10 kg disc which is kept and the center of a shaft जिसका diameter 30 millimeter है, length 500 millimeter है. So this entire length is 500 millimeter, right? And this shaft का जो dia है that is given as 30 millimeter. Why shaft dia is required? To find out the moment of inertia of this shaft. Shaft is taken as massless, as equivalent mass of shaft is in the rotor mass only. Good. It is mounted at the end. Bearing is assumed to be simply supported boundary condition. Simply supported beam ले लो इसको. Shaft is made up of steel जिसके लिए E का वैल्यू उसने दे रखा है. What is the value of E for shaft? He has given you 2.1 into 10 raised to power 11 पास्कल. ये उसने शाफ्ट का मॉडुलस ऑफ इलास्टिसिटी दे दिया. व्हाट इज क्रिटिकल स्पीड ऑफ रोटेशन ऑफ शाफ्ट? जब मैं आपको वर्लिंग ऑफ शाफ्ट कराऊंगा तो क्रिटिकल स्पीड होती है नेचुरल फ्रीक्वेंसी के बराबर. इन हर्ट्ज उसने पूछा है, नेचुरल फ्रीक्वेंसी के बराबर होती है. अब व्हाट यू शुड नो इज कि अगर मैं तुम्हें सिंपली सपोर्टेड बीम दे दूं और उसमें बीच में W लगा दूं तो डिफ्लेक्शन, जिसको स्टैटिक डिफ्लेक्शन भी बोलते हैं, डेल्टा, that is equal to WL cube over 48 EI. E दे रखा है. How do we calculate value of I? I can be calculated as moment of inertia, you know, pi d raised to 4 by 64. So let's take this as the diameter. So what is I? I is the moment of inertia of the shaft, pi d raised to power 4 by 64. I निकल जाएगा. E दे रखा है. W is nothing but mg. L दे रखा है 500 मिलीमीटर. डेल्टा निकल गया. तो हमारे पास नेचुरल फ्रिक्वेंसी is nothing but g over delta, and that is equal to 2 pi fn. The rest is calculation. See carefully. This is a simply supported beam. Loading is at the center. So what is the deflection under that load? For WL cube over 48 EI. ये फॉर्मूला कहां से आया? स्ट्रेंथ ऑफ मटेरियल से आया. W क्या है? mg. m कितना है? 10 किलोग्राम. L क्या दे रखा है? 0.5 मीटर. E क्या है? SI यूनिट. I क्या है? पाई डी रेस्ट ऑफ 4/64. Fn निकल जाएगा. एंड Fn जब तुम आंसर निकालोगे, that is coming out to be 90 hertz. So Fn will come out to be 90 hertz. As I told you, in GATE exam, you need to be very, very meticulous about the calculation. He might give you a cantilever, एंड में इतना किलोग्राम लोड लगा हुआ है, उसकी वाइब्रेशन, नेचुरल फ्रीक्वेंसी ऑफ वाइब्रेशन बताओ. तो कैंटिलीवर में यू नो द वैल्यू ऑफ नेचुरल कैंटिलीवर में डिफ्लेक्शन डेल्टा, यू नो द वैल्यू ऑफ डेल्टा. फ्रॉम दैट डेल्टा वी कैन कैलकुलेट द frequency, natural frequency of the vibration. So that was question number 11. Sorry, question number 12. Now next question is question number 13, and it's a good question. Torsional vibration का question है. I'm giving you question number 13. From where I'm reading this all questions, I've already sent you this 20 questions, you know. I'm going to give you 20, 20, 40, 60 question. Let's say 60 question mechanical vibration. All solving here. वहीं से एग्जाम में क्वेश्चन आएगा, यू नो. सो इज गिविंग यू दिस क्वेश्चन. दिस इज द क्वेश्चन गिवन टू अस. ओके, यही तो सॉल्व किया अभी हमने. डिस्क ऑफ मास m, डिस्क ऑफ मास m is connected to spring of stiffness k. Disk rolls without slipping on horizontal surface. What is the natural frequency of vibration? Disk rolls without slipping. That means this C point of contact becomes instantaneous center. This is the I center. मतलब entire rotor is going to oscillate about this point of contact, not about its center. मैंने आपको वही बताया इसका कैसे निकालना है. अज्यूम कि मैंने इसको थोड़ा सा थीटा रोटेट किया. लेट्स से रेडियस इज r. तो r थीटा स्प्रिंग के बीच में डिफ्लेक्शन आएगा. और अगर मैं इसको ऐसे रोटेट करूंगा तो क्या होगा? आई मोमेंट ऑफ इनर्शिया अबाउट सी पॉइंट इनटू थीटा डबल डॉट, जो हमने इक्वेशन बनाया वो इसको वापस लाने की ट्राई करेगा, प्लस स्प्रिंग फोर्स. कितना है स्प्रिंग फोर्स? आर थीटा. एफ इंटू आर भी इसको वापस लाने की ट्राई करेगा. एफ क्या है? स्प्रिंग फोर्स है. तो एफ इंटू आर मूवमेंट कितना प्रोड्यूस कर रहा है? स्प्रिंग फोर्स. स्प्रिंग फोर्स ऐसे को लगेगा, इस पॉइंट पे स्प्रिंग फोर्स लगेगा, और वो स्प्रिंग फोर्स आर डिस्टेंस पे लगेगा. तो आईसी इंटू थीटा डबल डॉट प्लस स्प्रिंग फोर्स इंटू डिस्टेंस ऑफ स्प्रिंग फोर्स फ्रॉम सी पॉइंट, वो उसको वापस लाने की ट्राई करेगा. ठीक है. थीटा डबल डॉट स्प्रिंग फोर्स है कितना सर? के इंटू आर. K into R is the spring K R theta KX. So spring force F is equal to K into R into theta. K into R into theta. R theta is nothing but spring compression. इतनी स्प्रिंग फोर्स लगेगी. अब IC है कितना? अगर मैं मूवमेंट ऑफ इनर्शिया निकालूं अबाउट सेंटर O पॉइंट पे, क्योंकि एक डिस्क है, तो mr²/2. लेकिन मेरे को मूवमेंट ऑफ इनर्शिया निकालना है सी पॉइंट पे. दिस विल बी mr²/2 प्लस mr². ये कौन सा फॉर्मूला लगा दिया? पैरेलल एक्सिस थ्योरम. आई कैन से दिस इज 3/2 mr². 3/2 mr². तो मेरे को ये बताओ, ये ओमेगा एन कितना आ जाएगा? ओमेगा एन इज इक्वल टू KR² ओवर IC इज 3/2 mr² अंडर रूट. This gets cancelled out. 2k by 3m under root. 2k by 3m under root. That is the answer of natural frequency of vibration. 2k by 3m under root. But you know what? If we ask you in Fn, so omega n is 2 pi into Fn. तो Fn कितना आ जाएगा? 1/2 pi. 2k by 3m under root. That is a question which was given to us. That is question number 13. Now, next question, 14th question. Let's go next, 14th question. There is an automobile engine for 240 kg supported on 4 springs. Let me give you, there is an automobile engine. There are 4 springs, on which this automobile engine is kept. Let's say this is the engine of mass M, 240 kg. And it is supported on 4 springs, something like this. There are 4 springs, right? With linear characteristic, front 2 springs have stiffness 16 megapascal. Newton per meter. 16 मेगा न्यूटन पर मीटर जो फ्रंट है, और जो रियर है उनका 32 मेगा न्यूटन पर मीटर स्टिफनेस है, राइट? इंजन स्पीड इन आरपीएम एट विच रेजोनेंस इज लाइकली टू अकर. लेट मी टेल यू, रेजोनेंस में कल करूंगा, लेकिन रेजोनेंस तब होता है जब इंजन की वाइब्रेशन, इंजन की फोर्स्ड वाइब्रेशन मैचेस द नेचुरल वाइब्रेशन ऑफ द सिस्टम. अब इसकी नेचुरल वाइब्रेशन बता सकते हो क्या? यस सर, नेचुरल वाइब्रेशन इज के बाई एम अंडर रूट. अच्छा, के कैसे निकालेंगे यार? ये तो सारे के सारे स्प्रिंग ही पैरेलल में लगे हुए हैं. These all springs are in parallel, right or not? If they are in parallel, तो कितना हो गया भाई? 16 plus 16 plus 32 plus 32 divided by m. लेकिन गड़बड़ मत कर देना, ये आपका मेगा न्यूटन है, 10⁻⁶, कुछ ऐसा निकलेगा, राइट? Let me see, this is 96. This will come out to be 96 into 10 raised to power. This is mega newton. 96 into 10 raised to power 6 divided by 240 kilogram. ऐसे निकालो. I don't know how much it this coming out to be. 632.46 रेडियन पर सेकेंड. और वो नेचुरल फ्रीक्वेंसी पूछ रहा है, आरपीएम पूछ रहा है, तो ओमेगा इज 2 पाई एन बाई 60. एक्चुअली उसने आरपीएम में आंसर मांगा है, तो ओमेगा इज 2 पाई एन बाई 60 एंड शुड कम आउट टू बी 6040 आरपीएम. You see, as far as the calculation is concerned, I can't help you. Calculation में you need to be good and calculator use करना start करो so that you guys become good in calculation. That is the thing, you need to be good in calculation, right? Now be attentive. Next couple of questions are going to be very, very important. So be very, very attentive in next couple of questions, right? So let me give you question number now. This question number is 15. See this diagram carefully. This question see carefully. आपके पास एक डबल लेग पेंडुलम दिया हुआ है, मासलेस रॉड ऑफ लेंथ L विद 2 पार्टिकल्स ऑफ मास M. इसका मास, इसकी लेंथ ऐसे दे रखी है. डबल लेग पेंडुलम हमारे पास दे रखा है, और वो बोलता है अगर ये एंगल अल्फा है, अगर ये एंगल अल्फा है, ये एंगल अल्फा है, तो नेचुरल फ्रीक्वेंसी बताओ कितनी होगी? What will be natural frequency of oscillation? That is a question. Good. Now, how to answer this question? Let me see what is this question now. Let me give you another diagram here. पहले तो ये ऐसे थे दोनों, इस तरीके का डायग्राम हमारे पास है. And let us say this is alpha, this angle is also alpha. Now what I do, मैं इसको थोड़ा सा नीचे की तरफ ले आया, तो ये थोड़ा सा ऊपर की तरफ चला गया. Let us say this is theta, let us say this is theta. Could you visualize what I did? मैंने इस एंड को इसके इक्विलिब्रियम, दिस इज द इक्विलिब्रियम पोजीशन, इक्विलिब्रियम पोजीशन से मैंने इसको डिफ्लेक्ट किया अल्फा, सॉरी थीटा, and then it goes theta this side, it goes theta this side. Okay, done. Can you tell me what is this angle now? And what is this angle now? This angle is alpha minus theta, and this angle is alpha plus theta. See carefully. This is the only thing you need to understand. This small angle is alpha minus theta. This is total alpha minus theta, alpha minus theta, और ये alpha plus theta. अब the weight component of this, if I take mg sin of alpha plus theta तो लगेगा इस तरफ, but mg sin of alpha minus theta लगेगा इस तरफ. See carefully. This mass goes this side. So mg sin theta plus alpha component will be acting this side. Mg sin alpha minus theta will be acting this side. Now, since I deflect it in this direction, let's say this point is O, then you know what happens is I about O into theta double dot. तो ऐसे को लगेगा restoring torque. I naught is the moment of inertia of entire system. Moment of inertia of entire system about O. अब इसमें इन rods की तो मास दे नहीं रखा, massless है वो, लेकिन इन दोनों का मास है. तो कैन यू टेल मी I naught कितना हो जाएगा? Moment of inertia of m about O is ml square plus moment of inertia of another mass is also ml square. तो हो जाएगा 2 ml square. Okay, done. What other moments will be acting which will bring it back? Another moment acting will be mgl sin alpha plus theta. mg sin alpha plus theta कितना मोमेंट बनाता है? into l. वो इस तरफ लगेगा, लेकिन इसका मोमेंट किस तरफ लगेगा? इसका मोमेंट लगेगा mgl sin of alpha minus theta, वो इस तरफ लगेगा. So there are three moments acting now. Equilibrium equation will be I naught theta double dot plus mgl sin of alpha plus theta minus mgl sin of alpha minus theta. Right? mgl sin of alpha plus theta minus mgl sin alpha minus theta is equal to 0. Understand? So iska moment and iska moment about O you have to calculate. Now this entire question reduces to I naught theta double dot plus mgl into sin of alpha plus theta minus sin of alpha minus theta is equal to 0. Sin A plus B, sin A cos B plus cos A sin B. Sin A minus B, sin A cos B minus cos A sin B. When you solve this question, certain terms will get cancelled out, and what is left is this: I naught theta double dot plus mgl into sin alpha cos theta minus sin alpha cos theta. Sin wali term will go out. So sin wali term will go out, and what you get is 2 times cos alpha sin theta is equal to 0. When you open it up, you get 2 cos alpha sin theta. Let me tell you from where it came. Sin alpha plus theta is sin alpha cos theta plus cos alpha sin theta. Sin alpha minus theta is sin alpha cos theta minus sin cos alpha sin theta. So this is what is left. Now theta double dot plus, should I go next page or how shall I solve it now? Theta double dot plus mgl over I naught, mgl over I naught. And you know, if theta is very small, sin theta is almost equal to theta. So this becomes 2 cos alpha is equal to into theta is equal to 0. And now this part mgl over I naught into 2 cos alpha, this becomes, let me create some space here. mg sine alpha plus theta into L. That is moment acting in this direction. Now, what is this part? Omega n is equal to mgl into 2 cos alpha, mgl into 2 cos alpha over what is I naught? 2 ml square. 2 ml square under root. That is the value of omega n now. If I solve, and what I'm getting here is m gets cancelled out, L gets cancelled out. This is G over L into cos of alpha. Let me check whether it is correct. G over L into cos of alpha under root. That is correct. What if alpha becomes 0? If alpha becomes 0, then this becomes single pendulum, simple pendulum. So this becomes cos 0 is 1. This is the answer for this particular question. And I think this was a good question. I hope you have understood this question. This was a double edge. So we just take two bobs, two masses, deflect it from its mean position by small angle theta. तो इसका भी एक movement रहेगा, इसका भी movement रहेगा, फिर then it is just like mathematics and you solve it. Next question is also interesting question. Next question is also very interesting question. So let me take that question. This is question number 16. ये हमारे पास दे रखा है एक मास ऐसे, and this is given as stiffness. ये दे रखा है, and this is the rod. Don't get afraid. These questions are simple questions. क्यों? ये दे रखा है हमारे पास 150 millimeter, this one, and ये दे रखा है हमारे पास also 150 millimeter. Let me read the question. A uniform stiff rod of length 300 millimeter with weight 300 Newton is pivoted at one end and connected to the spring as shown. For keeping rod vertically in stable position, what should be the minimum value of spring constant K? ये vibration का question भी नहीं है basically. W is given 300 Newton. This is not the question of vibration also. This is the question of, I think, only equilibrium. Right? So this is the question of equilibrium only. How to find it out? The moment you displace this mass, that let me give you this diagram again. Right? So this is the equilibrium position. Now, do one thing, displace it's from its mean position. Let's say like this. Displace it from its mean position like this, right? Let us say this one is x1, this one is x2. मैंने उसको उसकी mean position से displace कर दिया. Okay, this is W. This side is the force K into x1. This is K. Just see, if I displace it from its mean position, तो एक स्प्रिंग फोर्स लगेगी kx1 and W will apply a moment at point Q, W into x2. See now, for having equilibrium, what will happen is K into x1, that is a spring force, will produce what moment at this particular point Q is kx1 into L, is to be balanced by W into x2. See carefully what I'm saying. This spring force, let's call this spring force as F is equal to kx1. So this F spring force, which is equal to kx1, will be producing the restoring moment with respect to point Q, and this W will be destabilizing it, W into x2. Why the movement of W comes into picture now? Because it is now displaced from its mean position. So what we want to find out? The question is spring constant we have to calculate. So let's see. Now K is equal to W x2 over x1 over L. Okay. What is x2 by x1? You know, similar triangle concept says that if these two ratios are equal, this length over this length is equal, then this length is proportional to total this length L, and this x2 is proportional to L by 2. So what I'm saying is that x1 by x2 is equal to x1 by x2 is equal to L total length over L by 2. So x1 by x2 is double. X1 is double the x2, right? So x1 is double than x2. So W by 2L. Now, are we given the values? Yes. W is 300 Newton and L is 300 millimeter. So 2L means 0.6, right? So 300 over 0.6 is 500 Newton per meter. 500 Newton per meter is the answer for finding this value of K. That is what we wanted to find. That is a value of K. Right? Now, similar question, let me give you question number 17. This is the question given to us now. Okay, now there is a rod where mass M is concentrated at the center. And you know what? One end is connected to the spring of stiffness K. Mass M is kept at half the length. This is L by 2. This one is also L by 2. And this mass is kept at length L by 2. For very small amplitude, no, I think in this case it is not L by 2, this is L. This is also L, this is also L. Okay, now rod is kept in the horizontal position in the beginning and there is a spring of stiffness K. For very small amplitude of vibration, neglecting weight of the rod and spring, undamped natural frequency. What will be the frequency? You know, do one thing. Displace it from its mean position. So the moment you displace it from its mean position, earlier it was like this. Right? And this was the spring. Now what we did? Now we displaced it from its mean position, right? By angle theta. This goes here. This is how much? This is now 2L into theta. That is a spring deflection. So what are the forces acting on it now? Backward. What are the forces acting on it? I naught theta double dot. Let's say spring force is F. F into 2L. Spring force is, let us say, F. So F into 2L also brings it back. So what is the equation we are getting? I naught theta double dot plus F into 2L is equal to 0. Theta naught plus F 2L over I naught is equal to 0. Can you tell me what is the spring force? Yes, spring force is K into 2L theta. Okay, K into 2L theta. Okay, what is the value of I naught? What is the moment of inertia of this entire system about O? System there is only one mass. So I naught is ml square. Okay, now what is omega n? Just see, K over M, 4K over M, L square gets cancelled out. 4K over M under root. That is the natural frequency of the vibration. 4K over M is the natural frequency of the vibration. That is how we do it, right? Okay. Now, next question, as I was telling you, question number 18. There is a cantilever beam having mass and uniformly rigidity. He has given you a cantilever beam having negligible mass and uniform flexural rigidity with length 0.01 meter. Frequency of vibration beam with mass is attached here. This mass is 0.5 kg. Can you tell me what is the static deflection if cantilever of mass of length L is given? The frequency of vibration of beam with 0.5 kg mass attached at the free tip is 100 hertz. So natural frequency of vibration 100 hertz is given. Mass attached at the free end is 0.5 kg given. And length is given as 0.1 meter. 0.1 meter is given as this. You are to find out flexural rigidity, you know, EI. EI is called flexural rigidity. That is what we want to calculate in Newton meter square. In Newton meter square, we want to calculate it. Okay, tell me what is the value of delta. This is mgl cube over 3ei, right? What is g over delta? 3ei over ml cube is the natural frequency g over delta. You know, k over m is equal to g over delta. That is omega n square. So I can say g over delta is omega n is equal to 2 pi fn. What is fn given? 100. What I want to find out, m is given, L is given 0.1 meter, f is given 100, ei I want to find out. So if you put all the values, ei will come out to be 0.0658 Newton meter square. As I told you, a very simple thing he is going to ask you from these concepts. So cantilever was given, deflection, you know how the formula is there, and in terms of deflection you calculate the natural frequency of the vibration. So what was question number 19? I gave you 20 questions today. We have reached to 19 question. Let me tell you what is the 19 question. Simple question again. This is the kind of system given to us. This is one spring and this is the another spring. Understand? This is K. This is also K. This is 2L by 3. This is L by 3. This point is C. This end is A. This end is B. Right? A rigid uniform rod AB of length L, mass M, is hinged at point C such that AC is L by 3, CB is 2L by 3. Point A and B are supported by springs of constant K. What is the natural frequency of vibration? What is the natural frequency of vibration? Now, let's do this way. Suppose this is the given to us as rod hinged at here, right? Now what I do, let's say, rotate it something like this, theta, theta. Can you tell me what is the deflection produced in the springs and how these springs apply the force? Now this deflection in the spring is 2L by 3 theta and this is L by 3 theta. This is spring force F1, this is spring force F2. F2 is nothing but 2L by 3 K theta. F1 is L by 3 K theta. You know, spring deflection, extension of the spring, compression of the spring. But you see one thing, the force of the spring is, in this case, no, wrong direction I made. This is a compression, so spring force F2 is acting this side and spring force F1 is acting this side. So basically, it is trying to restore back it into this way. What is then movement of, what is then restoring torque? IC theta double dot. IC theta double dot. So what equation we are going to get? IC moment of inertia of entire mass, that is only rod, spring do not have mass, So what is the moment of inertia of the rod about point C? Because C is the point of rotation. IC theta double dot. Yes, good. What is the moment F1 is producing? F1 is producing moment F1 into, you see this distance, this is L by 3. This distance is L by 3. So this will become F1 into L by 3. Okay, done. And F2 into 2L by 3 is equal to 0. Because how far is F2 from this? This is 2L by 3 and this is L by 3. Okay. IC into theta double dot plus F1 is L by 3 K theta. L by 3 square आ जाएगा K theta. यहां पे भी 2L by 3 square आ जाएगा K theta is equal to 0. Good. Then can I say IC theta double dot plus, now theta taken common, L square K L by 3 square taken common into 4, this is KL square, 1 plus 4, that is 5, into theta is equal to 0. So if you add these two terms, these terms will come L by 3 square into K, 1 plus 4, that is 5. So theta double dot plus 5K L square by 9 IC into theta is equal to 0. Now, you know, L, we need to find out what is IC. We need to find what is IC. I know the moment of inertia of the rod about its G point. That is, I about G point is ML square by 12. Right or not? And what is this distance? How much is this distance left? How much is this distance left? This is L by 2 minus L by 3. So total this distance is L by 2 up to centroid. L by 2 minus L by 3 is L by 6. This distance is L by 6. So what is moment of inertia about C? IG plus ML by 6 whole square. So ML square by 12 plus ML square by 36. It comes out to be ML square by, if I'm not wrong, 9. ML square by 12 plus ML square by 36 comes out to be ML square by 9. And eventually omega n will come out to be 5K over M under root. 5K over M under root. That is a value we are going to get. 5K over M under root. Again, I tell you, this is a beautiful question. There's a body which if you deflect about the mean position, it is going to come back. Okay, with lot of this thing, we have come to an end of this session now. This is the last question. Let's complete this question also. 20th question. Let me complete this question here. Now, this is the system given to us. This is the system given to us. There is a mass M attached and there is a spring which is attached somewhere here. Now this length is A, this length is also A. This is spring stiffness K. You are to find out, there's a massless rigid bar OP which is hinged at point O. This point is hinge point. There's a mass attached at point P. नेचुरल फ्रीक्वेंसी ऑफ ऑसिलेशन निकालना है. तो कैसे करेंगे इसको इसकी मीन पोजीशन पे डिफ्लेक्ट कर दो थीटा एंगल से. तो बताओ ये कितना डिफ्लेक्शन हुआ. दिस x इज इक्वल टू a इंटू थीटा. तो स्प्रिंग फोर्स लगेगा. स्प्रिंग फोर्स कितना लगेगा? k इंटू एक्स लगेगा. k a थीटा लगेगा स्प्रिंग फोर्स. ओके, लेट्स से I naught theta double dot. Is there any other force which is going to bring K into spring force is also going to apply the force, and the spring force is going to apply restoring torque as F into A. You will say, sir, why mg is not being considered? See carefully, mg was producing the moment at point O before I deflected it by theta also and after that also. So effect of mg will not be taken. Listen carefully. Mg was producing the moment at point O before deflection also. So it is already taken care of. mg का impact is already there. After deflection mg ने movement नहीं produce किया, पहले भी produce कर रहा था. So only force, spring force is new, which produces the moment at point O as F into A, distance is A, and this one. So what is the equation now? Equation is I naught theta double dot plus F into A is equal to 0. What is I naught? I naught is the moment of inertia of this M about point O, that is M into 2A square. Distance is 2A, right? That is okay. Now theta double dot plus what is F? K A square theta over I naught is equal to 0. So omega n is K A square over 4A square into M under root. A square gets cancelled out. K over 4M under root. K over 4M under root is the omega n. That was the answer for this. So I believe you people have understood this mechanical vibration lecture 1. I will take, I think, tomorrow I will take again mechanical vibration. अगर कुछ बच गया तो मैं third lecture लूंगा, but अगर नहीं बचा तो in 2 lectures we will try to complete it. Believe me, you have to do only this, nothing else. Go to the exam, solving the questions, and I will send you this both the documents on the WhatsApp group just now. Revise it. Lecture सुनो और इन questions को revise करो. Gate is very simple. Don't make it complicated. Simple questions आते हैं and you can solve it. Fine. Okay, thanks a lot, all of you. So let me now save this particular thing. Yes, it goes down. I didn't save it anyhow. Okay, so thanks a lot, all of you, and we meet again in the next class. Thank you.